scalable deployments in an automated way into Kubernetes. And then I'll let Nima talk about the last two topics.
Hey, Nima, another solution engineer on the team. I'll speak to, I guess, Kubernetes engine and Istio. And I guess we'll go through, there's one thing you're going to learn is there's a lot of different ways to do some things, and some of them are core to Kubernetes, and then there's third party and then best practices. So hopefully we can help you kind of navigate that, because it can be overwhelming.
Yeah. And we love to just get feedback from you as we go through this. Like if you already know this and you're like, hey, Chris, we don't really need to go into this, or hey, I'd love to know more about how this works because it's confused me before. Feel free to jump in and just talk to us.
I'm Anthony. I'll just be helping throughout. Also a customer engineer based in San Francisco that focuses on Kubernetes.
So I had some specific questions around Firebase auth in the last session. I'm not sure if you're gonna cover part of that or.
I think if you had a continued question regarding Firebase auth, maybe it's better to follow up directly with Eric and not in this forum.
Okay.
Yeah, would that be good?
Yeah.
Excellent. I'll let you guys get to it. And yeah, it really is your time, your session. And as Chris said, it's kind of, we have some opinions around some things, and we've seen a lot of the pitfalls. So definitely ask the guys I know you've tried some things already, so should have let them know what you've already done, what's failed, and what you want to get into more deeply. So without further ado, Chris, I'll let you go from there.
All right, sweet. Okay, so Kubernetes, I'd love to talk about maybe just why this system came about. So assuming you want to build a microservices architecture, you see that here. I don't exactly know what your architecture will look like, but presumably you're going to break out into different services. The front end might be a component, the back end might be a component. You might have authorization components separately. So you can kind of package that with containers, right? That gives you the nice packing of each container, and it gives you more isolation, better resource management. But once you deploy this into production, how do you get these things to actually talk to each other? How do you deploy it? How do you orchestrate these things? How do you make sure these things stay alive? There's a number of different things that, like today, if you didn't have Kubernetes or any orchestrator and you wanted to deploy containers in production, there are a lot of things that you would have to address. And we're going to talk about some of these things: scheduling, health checking, logging monitoring, service discovery. How do you do rolling upgrades, rollbacks? The networking component, like how do you even make sure these things talk to each other? How do your users talk to these things? Again, if you don't have one today and you wanted to build it from scratch, like all of these things would be something you have to address, right? And part of being a good engineer is like, well, if it's already been built, can we leverage a tool that exists out there? I actually talked to a customer last week where at the time they wanted to do container deployments, and they built their own thing. And it was like this super kind of hacky system where it just like deploys things, but it forgets everything and has no notion of state. It can't tell you what it's deployed at a given time, can't give you the state of what's running. And that's where you really start to see a lot of these pain points. And so that's really where Kubernetes comes into play. Like this was designed so that if you want to do containers in production, kind of alleviate these pains for you so that you can run things in a production-like manner. So hopefully, brief intro to that. If you talk about, so there are lots of different orchestrators out there that address the topic of containers at production scale. You may have heard of Mesos, you may have heard of HashiCorp Stack, right? So where Kubernetes comes from is really from our learning at Google. So has anyone here heard of Borg? Besides Google. Okay, so at Google, if you're a software engineer at Google, like everything gets deployed in containers, and I think we have some crazy fact of deploying like over billions of containers every week or something like that. That system that handles that is Borg. We built that because this was like, I'm gonna say over 6 years ago, maybe. Like there was nothing out there that could do this, so we built our own system to handle that. There's a paper that actually talks about what was the problem, how do we build it, here are all the things. At the end of that paper, the engineers wrote like, we built the system, but there's like 12 things that if we could go back and do it again, like here's what we would do differently. That is really the birthplace of Kubernetes. They took that and they were like, wow, like port management is just like god awful. In Borg, like there's no notion of deployments versus stateful sets versus jobs. We'll get into kind of what those things are. Like it's just this one abstract job term. They're like, wow, that's really painful because our application developers are hard coding some of that logic by themselves. It is becoming a really difficult to maintain system. So what we did at the time was, hey, there's an even better way of doing this, and let's open source it. And that's like the best gift, I think, in this like community that Google could provide, right? To make it open source, to let other people contribute to this great system, and now you have like really the best learnings of container production, container deployments at scale, right? So that's kind of where the birthplace of Kubernetes came from. You know, the notion is really trying to get you away from like node management. Like today, you might be doing like virtual machines. Like if you want to do containers, you really want to get away from that, right? You really want to think about, I just care about my container. I don't care where it runs. Like just there's a pool of resources, run it, right? And run it intelligently. That's really the goal. And so what it really comes down to, right? It was built a couple of years ago. It's now been contributed to the Cloud Native Computing Foundation, right? Open source community of many different technology companies. It's written in Go, and it's organized by what's called special interest groups. That really just means that Kubernetes has a lot of different moving pieces, so each group handles something differently, like the authorization versus the deployment versus the stateful set components. If you're interested, you can actually follow what they're thinking. Like they have like meetings, I don't know, quarterly, monthly. They actually post their notes on it's like public. It's all open source, so you can see what they're thinking. You can also contribute back to it, right? The whole glory of open source is that you have a voice in this, right? In this roadmap. And then the most important perhaps is the K8s shortening. It literally means K8s because there are 8 characters between the K and the S. So yeah, I hope that.
Some people will type K8. That's wrong.
It should be K9, right?
Some people will use that, or K9, that's a typo.
If you take anything away from today, it's
that. Any questions regarding kind of the birthplace, the history? I know we'd love to get into the text. Okay, cool. Alrighty, so I'm going to start with kind of the 10,000 foot view and then sort of core concepts, right? If you've never used Kubernetes before, here's like the basic stuff you should be aware of. This is how it works at a high level, right? Your developers yourselves are gonna like deploy, you're gonna ask Kubernetes, can I please deploy these containers, right? That will hit the master control node. That control node is trying to accept what is your intent, what do you want to deploy, right? That's the purpose of that. The master then will go out to different nodes. Those nodes are, you know, part of your pool, and they actually run your stuff, right? Like, and they have different services. We'll talk about what they actually do. They're in charge of making sure they're running what they're supposed to, right? Your end users, right, the lab technicians, the different end users you have will hit directly those nodes, right? They don't go through the master plane because they're not controlling your system. They're not trying to change the state of it. They're just trying to access your application, whatever you deploy. Those are the 2 entry points at the high level.
The master is a node itself managed by Kubernetes, or it's always running?
Yes, we will talk about that. If you did Kubernetes by yourself, you'd have to deploy it yourself and manage it. And there are different ways, single node, HA style. In Google Kubernetes engine, we'll talk about the delineation, but essentially we manage the control plane. So everything from that to the left is, or sorry, that plane right there is something we manage. We'll talk about exactly what we actually do.
So each of those are like different pieces of software. They're different components. Theoretically, you could deploy them across different nodes, right? As each of these are different services. So the scheduler, and Chris will get into that, but typically they're either grouped into one specific node, or you'll keep your data store and then all of those other services separate on 2 different VMs. But in GKE or in Kubernetes engine, there's an opinionated way of how that's done. So
Yes.
because it's managed by Google. So.
Yeah. Fair enough.
Okay. All right. So you want to deploy things into Kubernetes. What are you even actually deploying? So the most important thing is the pod. The pod is the core atomic unit that actually runs your container. Right? and hopefully you may have heard of this, right? What it essentially is, it's basically like a Linux kind of abstract isolated box where it shares a networking and storage namespace. So all the containers that you run inside that namespace share that, right? So they can both talk to each other over a local host. They can attach a volume, and they can both look at what's being stored on that volume. Each of those containers runs a separate control group. It's called a C group. That's really where you tell it like, hey, this container should really only use up to, X unit of CPU, Y unit of RAM. Those can have separate control groups, but the namespace is what really groups it together, and that creates one unit called the pod. Right? We'll talk a little bit about how you use the pod. Right? Totally okay if you want a one-to-one, one pod to one container. Totally fine pattern. We'll talk a little bit more about why you can do like one to n, etc.
So what you're showing on the right, is that what a pod is?
Yes. This is what it actually looks like when you deploy things. There is a YAML manifest on the right that says in Kubernetes language, basically, this is what I want to run, right? My app, my Nginx SSL service, here are the ports I want it to run on. You construct this YAML file, right? And you give it to the master node saying, this is my intent, this is what I want to be deployed. The master takes that. We'll talk about the different software that runs on the master that takes it, and it's like, okay, this is what you want to do. Like, I'm going to actually deploy it onto your node. The pod goes, boom, it's there, right? By far the most common, well, we'll talk about deployments, but like the pod unit is what gets deployed in Kubernetes at the end of the day. Okay. Any questions? All right. Okay, so as I mentioned, this is the single unit. Some very important things though. The pod itself is not resilient. So if the pod goes away, it's gone. It has a very ephemeral IP. Like every time you bring it up, it just gets this random IP from a range. As I mentioned before, you can lump together many different containers. The canonical example of why we allowed this, right, is because and it's more of like the sidecar pattern where you have your application container, it's doing something really important, but you have this other thing that needs to watch the results and may have to do something else with it. So for example, your application is writing logs to standard out. And you're like, well, I need to have another container that's watching those to pipe it somewhere else because my monitoring tool is in location Y, right? So you run a sidecar that takes those logs and pumps it out, right? And you say, well, no matter how many application pods I deploy, every single one of those should have this sidecar type of container running, right? And so that's a couple of units essentially that gets deployed. When we talk about Istio, we'll actually get into what Istio actually does in terms of the sidecar and what it deploys. I think this concept can get really confusing for some people because they're like, well, in that case, like, can I just deploy my front end, back end, everything as multiple containers into one unit? That's really not the intent of the pod, right? You really want every layer of your software stack to be separate and separately scalable, right? If you're lumping your back end and front end together, then you're scaling those as one unit. At that point, you've lost the whole kind of purpose of containers in the first place, right? So just keep that in mind. Again, in the simple case, if you just want one container, one pod, we see that pattern, nothing wrong with that.
So the sidecar is a container within the pod, a single one? Or?
Yes. So like imagine the blue box being your app container, and then the blue box on the right being your sidecar logging container, for example. Two separate containers in one pod.
And we would define those specifically in the YAML definition?
Yes.
Or okay. Yeah. And would the footprint of a container of a sidecar be any different from any other container? I mean, are there any limitations?
The sidecar is actually more of like just
a
concept
filter.
Yeah, concept.
I see. Okay.
You could just run n containers in a pod.
So how do you differentiate to make sure that it can do kind of the external like log? It's just for design. It's not having any specific access limitations or
Correct.
network
Yeah.
properties. I see.
Yeah,
Okay.
that's why it shares that network namespace, right, over localhost.
Mhm.
They can talk to each other on localhost, right? It's one. Whereas
Right,
traditionally
right.
you have to like go over the network and hit another IP or something like that.
So
It's definitely one.
But if it's just a design concept, then why did you come up with this entity in the first place? I mean, what is the why would we not create any kind of subset of containers within a pod to handle any kind of scenario that this particular pod needs to do? So for example, one container for logging, another one for I don't know, managing some kind of persistent storage updates, and then a third one. What is the reason behind this design?
So in the example of like the logging, for example, right, you might have a logging container, right?
Right.
It doesn't have any notion of what your app does, or
Exactly. Yeah.
it just says like, give me a location, I'll watch it, and I'll pump it somewhere else. So that container is reusable, right? So whether it's your app container or database container, right? That's
I see.
so then when you deploy your pod, you can say, well, my app
So
with
it's
my
basically almost like a factory design, just on a pod level.
yeah.
Ish.
Okay. I haven't thought of those in a while.
Okay.
Patterns.
No, I'm just wondering, where that came
I
from.
guess the question is what's the boundary, or what differentiates, or what tells you that it's okay to define this container within the pod, or another container should be another pod by its own? Like the definition of another pod versus can this
I guess it's just the local host,
can
right?
this service be
That
within?
you have
So
it on the
if
same.
we are sharing these resources, then
Yeah.
it becomes it can be a container within the pod.
I mean, it's usually a logical separation of your overall app, right? If you have your front end, it should be your, for example, the web server, your Nginx, for example, right? And whatever code you have running on React or whatever front end framework you use, you can have that. And then if you have your backend, right, with your databases or anything, your nodes and so on and so forth, you have your logical separation of those two. And there's nothing necessarily forcing you to like separate these things, but you design them the way you would think of, are you going to have the same team working doing your React development versus your Node.js development, right? So they become separate. So that separates the concern between the teams, right? So they become separate things to update and roll out different versions and so on and so forth. So it's very much from a design perspective is like, okay, how many logical microservices, are there in the system? And that kind of drives you towards, okay, these are the different pods, and in them they have containers. So the front end means 3 specific containers that you want them, even maybe from performance perspective, you want them to be, make sure that they're in the same pod, therefore they're in the same node, right, in the same actual physical VM versus your backend, and so on and so forth. And then you have that system set up, right? And then, but you say, no matter what, I want to have logging on every pod. It doesn't matter if it's front end or back end and so on and so forth. So that now takes you to the notion of a sidecar, or Damon said, which Chris will talk about. It's like there's specific containers that you want to have on every pod, no matter what, right? Logging would be one of them. So these, like, it's just like a terminology of you do all of this anyway, but now you deal learning. A big part of it is learning the new terminology of that, what that means in the world of containers and.
So I'll use a real example from like last week. So I was deploying sidecar proxy for to connect for our app server to connect to Cloud SQL.
Mhm.
Right. So I went to documentation. They said you should install a sidecar proxy exact same way within the pod, which is an actual proxy. So I was, as a newbie, I was thinking, okay, maybe I can install a central proxy on my whole K8 cluster.
Mhm.
So that server itself is a proxy server. If I connect to that, because I am able to connect to that within my cluster, and that one can connect me to Cloud SQL. So all of my pods can talk to that single proxy. But the way it's prescribed is this way, that you install that proxy as a sidecar within each pod. So each pod has its own proxy. So you see my confusion, like.
So both are possible.
Yeah, okay.
the question is more around your design of what makes sense.
Okay.
Right. So if you have one central proxy and you give it like a giant box, but you like say you have this enormous traffic coming through, you're gonna hotspot that.
Yeah.
It's gonna like melt, right?
Okay.
So then at that point you're like, well, I need to start distributing it. So how do I distribute that, right?
Okay.
So that's one way of distributing that proxy.
Okay,
right?
so there's no technical.
There's no technical constraint
limitation
from doing one or the other.
to do it. Okay.
Yes,
Got it.
exactly.
It's conceptual.
Exactly.
Yeah, and I mean, as Chris said, your proxy can become something that
Right.
more and more traffic, now you run a few of them, and now you realize, oh, now you have a bunch of pods representing that proxy, which then it's gonna sit behind the service because now you don't want other pods trying to find out where it is and so on and so forth.
So yeah, so technically, right, it's you've got one pods and containers, right? Then you've got your design.
Right,
And
right.
depending on what your design, you can.
No, I think that makes a lot of sense. I think for a while we thought, that this sidecar concept was actually more than just a design principle. It was maybe restricting or allowing you to do certain things.
Yeah.
But if it's just a pure design concept, then it makes a lot of sense because I do see this pattern to be fairly useful, especially for things like logging, right? Like you mentioned, Nima, in almost all pods, you probably want to build in logging mechanisms, but you don't want to copy or maintain multiple nodes or multiple containers with similar code, right? So you want to just have the same.
That abstraction and separation, again, it also helps with the separation of concern in terms of you have those who are managing and administrating your Kubernetes cluster, and therefore they're the ones dealing with the sidecars, which for example is logging. And your developer should know nothing about that, right?
Exactly.
They have their application, they got a dashboard and they go look at logging. They don't care how this logging is happening. So, that has nothing to do with the actual source code of the front end, right? But it is a container that sits just like the other container that sits next to it, but different teams, different concerns, right? Now, in case of smaller teams of 4 or 5, it's everybody's concern.
Right.
But I mean, again, the idea of microservices and everything Kubernetes, it's about building something that can scale and it can be separated. And
Yeah, no, that makes a lot of sense. Are there any, moving on, are there any best practices in terms of how you want inter-container communication to happen?
Yeah, so we will talk about how to expose different sets of pods, right?
Okay.
So within the pod, the containers can talk over localhost, right? They have as close as they can be. And then they're on separate pods. How do you get those to talk to each other? And we'll talk about how that.
yeah, I think we can, we'll go quickly because actually, so 3 hours is very few number of minutes to cover, a lot of this stuff. But we'll go, Chris, myself, and we'll go pretty quickly. We'll go through list of topics. And then I think after we can decide what to
Dive deeper on, yeah.
dive deeper.
Yeah, sure.
Yep, let's do it.
Yeah, we'll try to cover it as much as we can. Okay.
Are you recording
So-
this?
Oh, okay.
All that said,
Thanks.
you actually probably won't be deploying a pod directly. And because when you think about container deployments, you're usually not deploying like one pod. Like you want a scalable system. So you'd be like, I want 4 copies of these, right? Because that's the amount of traffic compute I need for my load. And so we came up with the concept of a deployment. The deployment creates multiple pods on your behalf and it watches them and sort of revives them when it's needed. So in practice, what that looks like is very similar. It just says the replica count, right? How many of these do I need? And then there's some sort of label that talks about like these containers have this label or these pods have this label, and that's how I can figure out which pods fit this deployment. So again, very similar. You declare that state, goes to the master. Master takes that, deploys 4 pods onto your nodes, right? Where it deems it necessary. We'll talk about how it figures out where to go, but this is essentially the core workflow, and most likely you will be using a lot of deployments, most likely.
And the deployments is always for the same pod, right?
Yeah.
Just to clarify, yeah.
Okay. And then we'll talk about services. So if you deploy these pods and make deployments, they're not exposed to your end users whatsoever, right? They're like in the cluster, like you can't get to them from the internet, right? And so the concept of a service is really how to create that endpoint where you can actually address all of those, right? So internally, right, what you don't want to do is say, I need to hit pod A and then pod B and pod C separately. You want to create one endpoint to front those four. But that's your internal service cluster IP. We'll talk about what those things are. And then there are ways to expose that externally to say, this is my load balancer IP where you can actually access it from the external internet. So that's essentially what the service is, exposing your pods to internal users and also external. Cool. Okay, and then finally we have namespaces.
I think there's a question.
Oh yeah, sure.
Quick question on the, so you're pretty much routing traffic through the service into the different pods, right?
That's right.
Is that, how is that routing happening? Because it almost, I mean, the diagram there looks very much like a load balancer or something where it's actually distributing traffic between them. How does it know which one to go to, and kind of what are the differences between a service and load balancer?
Yeah, so the summary is internally, Kubernetes will create what's called a cluster IP. It's a virtual IP, only internally accessible, right? Anywhere in the Kubernetes cluster, if you say hit this virtual IP, right, that will automatically figure out, okay, this IP maps to these 4 pods, and it'll load balance across those 4 for you internally. That's internal. Externally, though, that virtual IP it's not like a public IP routable over the internet, right? So what we can do, especially in GCP, is we'll create a load balancer that fronts that and says, here's a load balancer, here's the external IP for that load balancer, here's the port. So if you hit that load balancer will then hit the nodes. The nodes will map to the service IP, and then it routes again. There's a little bit of multiple hopping there that can get confusing, but in general, for the summary, there's an external load balancer IP if you need it, and then it'll hit the cluster IP, which load balances across the pods inside.
Why would you need the external one if you have the internal one?
The internal is only accessible in the cluster.
I know, but why would we want to care if it already manages the load within the cluster?
Right. So
Oh, you mean
Only if we want to expose it. If we want to expose it to our customers.
I see. Yeah.
So,
Okay.
so let me give you a little more context. So the reason I'm kind of asking is we're kind of going through a couple different iterations on how we want to expose our internal services to each other. One of the mechanisms we're really looking at is gRPC. But with that, it's, HTTP2 transport, and want to make sure whatever we're putting in front to balance that can actually manage that correctly. So that's some context around it, and hopefully that helps later on as we have more specific questions.
Okay, yeah. Awesome. And then there are namespaces. So within a cluster, you can create different namespaces. They're sort of logical, isolated groupings, right? Generally used for things like RBAC to say, team A can have this set of resources in this cluster. Team B can access this set of resources in this cluster. And those are in 2 different namespaces. I think you can have as many namespaces as you want within a cluster. And so it's really just a way for you kind of distribute the organization of your team's access and also quota, right? This is especially important in large organizations where you don't want team A to be like, oh, max out everything, and then team B can't deploy anything. So that's where it becomes really important.
How does this map to projects?
Right. So in GCP, a project is a really high-level, completely isolated group of all of your GCP resources.
So this is just a subset.
This is very, very subset.
I see.
Within GCP, you'll have a Kubernetes cluster. You can have multiple clusters.
Mhm.
Within each cluster, you can have multiple namespaces.
I see.
Should we whiteboard the hierarchy? Or
No, I already read about it. So no, I just wanted to make sure I get it straight.
Yeah.
Cool.
All right. Sweet. So then we want to talk a little bit about architecture. We get to the Nima's portion on GKE. He'll talk about what we actually manage. But if you were to stand up Kubernetes by yourself today from scratch, all of these would have to be deployed by you. And so we'll talk about each of these components, right? First with the master, and then what needs to actually run the nodes themselves. Again, to have all of this work for you, right? So on the master side, right, the master the job is to know first of all, what is the state? Like, could I even query out and figure out what's the state of things running? And then also, can I receive requests from your team to be like, I want to deploy this, can you please do so? The master itself can be a single node, or it can be horizontally available, which is essentially, I think, up to 3 nodes to make it, highly available, so that one node isn't a choking point. These are all the different components. I'll get into each of these. So very importantly, though, the master does not execute your containers. It doesn't actually run anything, right? It just receives state and it receives intent, and it tells the other systems like, this is what you actually intend to do. The rest will figure it out. We'll show you that diagram. The most important, arguably, is the API server. Like every time you write, and you'll see this probably in the lab, like a queue control cuddle command that goes, it hits the API. Like, this is how you communicate. This is how you talk to the master node. Like, this is what I want. And it validates all of those objects, and it supports multiple different operations. The etcd is the backing data store. This is where everything's sort of, it's storing all of your state, right? And I talked about this earlier. You build orchestrator yourself. You want to be able to figure out, what did I deploy, right? etcd captures everything in terms of what are you running today? All that data is sitting in here, right? etcd itself can be distributed to be highly available. We'll talk about how GKE takes care of that.
So basically, like whenever you're creating like that deployment object, that pod object, or when you're creating a service, there's basically all of these are just resources that are stored in etcd.
Yeah.
Right? And so
actually really important also for it's Istio. It'll be part of that too. The scheduler. So while the API server says like, hey, you tell the API server, this is what I want. The scheduler is actually the loop that figures out, okay, you want to do this, I need to actually schedule it to make it actually happen, right? That's the core piece of software that runs this. By the way, if you're curious about the code, again, it's all open source. So you can actually see the scheduler Go code if you're interested and you want to really dig into how it works. It's all open source. The scheduler has like sort of a sequence of events that it goes through to figure out how to actually deploy your stuff. So the first one is, okay, based on your request, right? Maybe it's the amount of CPU you want or the amount of RAM you want. It's first going to do a filter, right? Out of all these nodes, which ones actually can even support this pod? The second one will then say, out of those nodes, what's the priority? What do I prefer to deploy on versus others? And then it chooses a node and finally actually runs that. We'll talk about how it actually runs. And then finally, we have the controller managers. This is basically everything else that needs to, all the other software to make everything else work, particularly with cloud controllers, right? When you talk about GKE, whether it's other providers, you need to have something that knows like, oh, you want a persistent disk. I need to actually call the your cloud provider's API to actually deploy that. That's the code that runs to handle that logic. Okay, so that's the master, right? All these components, again, if you deploy this yourself, you'd have to deploy it all manually. On the worker itself, the most important is a kubelet. This is basically your node agent, right? This is the agent that talks to the API server, tries to figure out, okay, like, do I need to actually run something? What is it? Here's my heartbeat to tell you that I'm even alive. So that's really an important component. The container runtime interface is the one that actually runs your container. So we recently kind of made this an open source compliant, open container initiative compliant runtime. So there's an initiative to make the runtimes you can plug into Kubernetes pluggable and open source. And so we'll talk about GKE. We support Docker, Rocket. There may be some others in the future. Keep that in mind as you take this journey into Kubernetes. And then finally, we have the kube proxy. I don't think I have nearly enough time to talk about how exactly this works, but essentially what it does is it figures out how to make your communication from pod to pod possible. Right? It does a whole bunch of work. importantly, like in the old day, it used to like take a packet like destined for somewhere else, and it actually brings it up to kubeproxy, and then kubeproxy like takes in like, okay, like here's what I want to do with it. Now it's actually more of a sidecar. It just updates IP table rules, and so the node itself will handle the communication. If you're interested in the gory details of that, we can share you the video. We can talk about it later. It's very low level.
Just quick question on the master. Is that something that comes pre-configured? I mean, can we just spawn it, or do we have to build it out manually?
In GKE, handled for you, which is beautiful.
Okay.
If you do it yourself, you literally like start like the scheduler like as a binary, and then you give it like 30 different flags to figure out.
So
It's like
GKE
beautiful.
is just
It's all boom down.
In previous diagram at CD, is that counterpart of Zookeeper, or
It's
are
the
they parallel?
it's the backing store. Like it actually, Zookeeper is more of like
Orchestration.
yeah. The etcd is like it's basically like the data store. It has your data.
Yeah, Zookeeper is built on top of etcd, right?
Okay.
I
So
think so.
yeah.
I see.
Follow-up question to the etcd: is that kind of the right approach to use for service discovery, or should we actually look into a separate layer to kind of sit in between that to manage the service discovery?
I think we have a section for service discovery in the advanced topics later. Can we
Perfect.
discuss it there?
Absolutely.
I think so, right?
Yeah, we can do that. Okay.
The short answer is that Kubernetes will give you abstraction so that you're not actually poking around in etcd
Yeah.
for service discovery, right? So
Yes. Yeah. Kubeproxy. That's all you need to know. If you want to go down the rabbit hole, we'll give you pointers on how to go down that rabbit hole. Part of actually service discovery is the DNS aspect. So instead of referencing all your services by IP, you can give it a name, right? And it resolves a name. That's Kubernetes. Right? We'll talk about how it actually runs in GKE, but you would need this add-on if you want to reference your other applications by name. Yeah. Okay. Alrighty. So I'm going to try to kind of wrap up the flow here. I'm actually just going to skip to this. So this is everything that happens if you want to make a deployment. It's actually a really good diagram. I highly recommend you look at it. You can share it with you. You can see the flow here, right? You hit the API server, say, I want this deployment. Maybe that deployment says I want 5 pods. You know, that persists that day in etcd, right? Because you need to remember what it did. Then there's the controller manager, which is like, oh, this is what you want to do. I need to actually create the thing that's going to do that. So it creates a replica set, and then that gets created. There's another controller manager that's like, okay, well, you want the replica set. Now I need to create the actual pods, right? So it says create 4 pods. Those 4 pods go out. The scheduler sees, oh, we need to actually deploy 4 pods. Where do those 4 pods actually go? Figures that out, tells the different nodes, this is where it needs to go. Each node has a kubelet, which watches it and says, oh, I, as a node, need to run this pod. I finally receive that request, I run it. Right? That whole flow is this.
That's awesome. Just to clarify, so we would not care for anything besides the first vertical.
That's right.
It looks complex, but yeah, you're just again writing that YAML file, providing that to the API server, and then this is kicked off.
Takes over everything. Yeah. No, that's cool.
Yeah, and that's the nice part about Kubernetes too, is that all of these controllers, the things that are watching, it's not just doing that at creation time, right? You declare your desired state once, and these controllers are always enforcing that. You can update that desired state, but those controllers continue to run, they continue to watch API server, and if something changes, whether like, let's say a pod becomes unhealthy or something like that, it will spin up a new, pod, depending on what you declare.
Yeah, very cool.
Yeah. All right. How are we doing? Pretty good.
Can I ask, is the application you're describing, is it a LIMS? Okay. Got it.
Kind of. I mean, I'm trying not to use that term as much because most of the LIMS systems out there today are like using 1990s Windows UI
Yeah, okay.
So we're trying to
Yeah,
move a little bit beyond that. But yeah, in essence,
I have a customer that will be set up wins on GKE as well. So
oh, cool.
I might,
That might be
poke around and
good
figure out
knowledge. Yeah,
what
exactly.
they're running. And I know they're running on GKE. They asked some questions there, but we haven't done like a full architecture. So I'm happy to
Right.
see if I can have anything that might be helpful for you guys too.
Awesome. Yeah. LIMS is a laboratory information management system. So it's just an acronym people use.
Tracking the
in-
samples,
Yeah, exactly.
workflows.
You got a perfect person.
I know. Yeah, let me know. We can talk.
Yeah, I will actually like circle with Faye after this and see what I can bring.
Thanks, Anthony. Get yourself the job.
All right. I wanted to, well, let's see. We did want to mention service discovery, but this is more kind of extending on, we talked about exposing your service to the outside world. How does that actually work in practice? Actually, probably we'll start with this. So these are the 3 different ways from just the service aspect of exposing your pods, right? So again, you have five pods as part of a deployment. Where you're like, I need something that I can hit those 5 pods with on a stable endpoint, right? The first and this is, by the way, this is cumulative, right? So the first option is the cluster IP, right? This is just an internal IP. Just give me an internal IP that fronts these 5 pods, and I can just hit that IP, right? Corresponding to DNS too, right? That's entirely internal. The next step to that, to say I want this to be exposed externally, is called the node port. So the node port, what happens is every virtual machine in your cluster will allocate a port, like literally to the external world, and say, if you access my IP on this port, I will route this to the service and the pods. So you could directly hit VM1's IP and say port 32,000, or VM2 port 32,000, right? And actually access that pod directly. But you don't really want to do that, because you don't want to be managing different virtual machine IPs, especially when we'll talk about auto scaling when your cluster is changing. That's the last thing you want to do. And so the real one you want to use is the load balancer. On top of that, it creates an actual load balancer. GKE creates an actual GCP load balancer. And then it basically fronts all of this, and so just gives you one stable external IP. You can integrate that into your own DNS however you want, and you can essentially get routed to your pods in a load balanced way. And we'll talk about GKE, what the service load balancer actually matches to. The second option is actually what's called an ingress. So if you choose node port, but you're like, I don't want the load balancer, there's also this concept of an ingress, right? So services operate at this L4 layer, right? Very like just bare bones TCP, go here, go here. If you want more of an application level logic, L7, right? Where you say, well, if you hit my app on / whatever, right? Like hit this service or / this, you want to do application level routing. That's what the ingress offers you. The concept is really the same though, right? You've got the cluster IP, the node port, and you create an ingress load balancer. It just is more intelligent, right? That's a very high level overview of that. And we'll talk again more about what that actually maps to in Google Kubernetes engine.
There's also for the service type load balancer, the ability to create an internal load balancer so that you don't have to expose it publicly, but it's the same concept that it maps to one specific service. Its ingress is again mapping between multiple services and operates at the layer 7 and gives you that like external bit.
Yeah.
So the internal load balancing, what kind of service would that be? That cluster IP or which one?
So that would be in GCP, and again, this is something that now we're in like Google specific way of Kubernetes. That's still a type load balancer. You just provide additional metadata in the YAML that signifies that, oh, actually create this internal to this network as opposed to like a publicly exposed load balancer.
So realistically, most of the time people should be choosing load balancer service type.
Yeah, that's like one of the patterns that we see. If you're fronting with an ingress, then you'll use node port. But I think for internal services, I think we're kind of pushing people to internal load balancers.
For example, if you want, let's say in your setup you've got a cluster, but you have like these virtual machines that are doing something totally different for whatever reason, and that virtual machine wants to access a service in Kubernetes over a private IP, right? That's the internal load balancer, right? Because again, the cluster IP is a cluster concept, right? If you leave the cluster, that's not like a routable thing. So that's kind of short of it.
And the cluster IP is IP stable?
It is stable, yes. It's very virtual in the sense that, again, it's not like outside of the cluster network. It's not really known, right? So.
Yeah, so there's like a controller that's, so as pods come and go, the IP addresses will change, right? So if a pod is terminated, a new pod is spun up, it won't get the same IP address. But basically there's a controller that's, if you create a service that is constantly updating that service to be associated with X amount of like cluster IPs. Or I'm sorry, cluster pod IPs.
Yeah, that's right.
I'm not clear on difference in node port and ingress. Is it just a layer difference or?
So ingress is very comparable to load balancer. One is L7, it gives you application level routing. I think we have examples in the GCP one, perhaps. And then
whiteboard it too. If it's easy.
Yeah. Whiteboard? Okay. All right, I can whiteboard. I'll try to do this fast. So think of it like this is none. So like if you don't want anything, the cluster IP, and then this is your node port. I guess everything up to here, this is internal. Sorry, I'll go here. And then everything here is external. And then from here you have two options. You have the L4 load balancer, and then here you have the ingress. I think with this one, you could do something more. What's like a good example? Like if you had like a video service, and you're like, well, my HD processing should go to my HD service versus, my standard should go to my standard service, right? You want this type of routing, right? Not specifically your case, but this can only be possible with the ingress. Yeah.
Yep.
Not possible. Sorry, we can't. I don't know how to.
I can take a picture.
I can.
Yeah, is that camera, can it rotate?
The camera.
It's
Yeah.
movable.
And there's a lot of things that, another thing that you can have with ingress is like, well, I guess it's not the Google specific, but the point of it is that you can like enforce sticky sessions and things like that with like Nginx ingress. So there's basically things that you just couldn't do with, again, like Chris said, a very simple like TCP load balancer that ingress really allows you to do, whether it's route by path, be aware of what's in the packet, right? And then make decisions according, like routed to different types of services or different pods. So
when you use GCP in general, one of the choices you'll actually just make as part of GCP is, are you going to front things with the L4 load balancer or the global load balancer L7? So, and we can help you kind of talk more about what those differences are. That's another way of thinking about it. Is like, what type of load balancer do you want? Right.
Yeah, it's good for now.
So to use,
Go in more details.
huh?
I said that's good for now for
Yeah,
my
sure.
understanding. Otherwise,
Yeah,
I
we
think
can
you
update.
are going to cover a bit
Yeah.
more on this one.
Are you guys clear on, Kader, Kazim, on deploying ingress? And how to set it up?
So we did so far with what you showed in the example, like in YAML file, you just say ingress, or you can also create a ingress IP or expose it using ingress, and that will give us an IP that we can use for the external from
Yep.
external. So that's what I've tried so far, but couldn't exactly understand the difference in load balancer and ingress from that exercise. So.
Gotcha. Yeah, we could also start by just looking at like GCP. What is the difference between the L7 load balancer and the L4 load balancer. Like for example, one of the biggest differences is the L7 load balancer is a global load balancer. You can hit that from anywhere in the globe. And it's like this crazy distributed system that can route anywhere. The L4 load balancer is regional. Like you can only say, I need this in US East. You can't. So there's bigger hops to get there.
Yeah.
There's lots of different benefits of that you get the global load balancer. So just understanding that could help. And this is just a way of getting one or the other. Right? It's one way of thinking about it.
And what about for internally then? If we needed, say, L7 because we're HTTP2 traffic gRPC use case. So if we want to be routing that through a load balancer, but we're only talking about internally, is that still an ingress or is that some other type of deployment?
Yeah, that's actually a good point. So, so technically, if you wanted the internal version of this, and you had the node port, you could get a L4 load balancer, and you mark this as internal. This creates what's called an internal load balancer in Google Cloud Platform. On the L7 side, I don't know, Anthony, maybe you can correct me, but I think you would have to use Nginx for the internal load balancer.
Yeah, no, there's no way you'd be able to use the
Yeah.
GCE ingress.
Yeah. And the cool thing with Nginx is they just released an announcement where they not only proxy gRPC calls, but they can fully I don't know what the term is, like actually route gRPC calls. So proxying usually means like you terminate the gRPC connection and then you just send off HTTP1 requests. But with the Nginx ingress, you can actually like continue to send gRPC calls all throughout your cluster, is the way I understand it. And they recently announced that support, so which is great.
Alternative to that is Istio, right?
Oh, yeah.
So we'll talk about Istio and what that does, but traffic routing internal to your cluster is a big part of what Istio solves from service discovery, and the traffic routing is L7, HTTP 1 and 2, and gRPC as well. And it achieves that by having a sidecar as Envoy. If you're familiar with Envoy, is a high-performance C++ load balancer, L7 load balancer that was created originally by Lyft, the ride-sharing company. So we'll go through that and show that.
Great.
Yeah, definitely check out the Nginx one for the gRPC, and also Istio. Okay, cool. Let's see. So there's, I guess, just to conclude, like there's a lot of other things in Kubernetes, like a lot, like quality of service, priority and preemption. We haven't even gotten to like stateful sets. How do you want to, if you want to deploy like multiple replicas of a database? So I encourage you to, as you take this journey, like check those out, like whether documentation or videos, we can help you point to some of those concepts if you're interested. We can also definitely just have a separate conversation.
Yeah, the Kubernetes own documentation, the concept section goes through the whole list. So as Chris said, there's about 25 other concepts that we are not covering here.
Yeah.
Cool.
So, hopefully with that, at least you have like a foundational understanding of Kubernetes. Like, let's just say your stateless services, you understand, hey, it's Kubernetes, write a deployment file, run it, and Kubernetes takes care of the rest and creates this amazing thing. And then you create a service to say, I want to actually expose that. And then that's like a very standard workflow for some of your stateless services. All right. So with that, I wanted to transition into CI/CD. I think that was one of the things the team wanted to discuss. So apart from doing this by hand, by that I mean like in the command line and just like SSHing into the node or just hitting the master, like you want a pipeline automated way of doing this, right? I guess before the slides, I wanted to just kind of show. Can I erase it, or I'll just do the high level? Yeah. And Anthony, you guys can fill it in. This is like my mental model of how CI/CD works. Let's see here. Okay, so in terms of like you're gonna have code, right? You'll have your artifact. Today it's probably a VM image, right? In the future it's going to be
Just send me.
a container image,
Thanks again for sending that.
maybe Docker. Right. We haven't talked about Helm charts.
Yeah, we'll start with the.
Yeah, let's start with just
start with.
And then and here's like your end state, which is, let's just call it the Kubernetes deployment for now. Right? It doesn't have to be deployment, but something running in Kubernetes, right? This is essentially the three things that you want, like that you kind of need, right? And like, how do you get from point A to point B? So this is roughly speaking kind of the CI portion in my mind. Obviously, there's testing and kind of that whole mindset, but there's sort of this like integration piece or testing your code, and you kind of want that artifact, and then there's the actual deployment piece. Like you need to take that image and you need to run it in Kubernetes. So what are the different options? On this side of the house, we have a Google product called Container Builder. I like to call this. There's also Container Registry. They're kind of they're separate, but in the console they're kind of the same. Using. There's definitely Jenkins in here. The other ones are Travis.
Circle CI. Are you guys using any like continuous integration tools presently, or?
We're just getting set up. I mean,
Okay.
Okay. Basically like, there's some kind of SaaS type, right, versions, and there's many more that do this, right? And then that helps you get your actual image, right? And then on the right, Kubernetes itself has some actual kind of deployment strategies to help you with this. We'll talk about what that is. Jenkins also. Also with the recently announced Jenkins X that has more native integration with Kubernetes. We support and contribute to a open source project called Spinnaker that was originated by Netflix. And they use Spinnaker to do all their deployments. We'll also talk about, Nemo will talk about Scaffold, which is something that we recently announced. I think it might do a little bit of this.
Yeah,
right? A little bit of both. And of course, your SaaS stuff and more. That's like the ecosystem at the highest level. The way I understand.
Are you guys familiar with CodeShip?
Yes.
Yes. So CodeShip is like, to some degree, like Jenkins in the sense that it will cover a lot of your CI and your actual like deployment and delivery workflow. So I think that kind of fits into the narrative of like what Chris is talking about as far as some of these tools will span between.
Yeah, exactly. I mean, CodeShip is the one I'm kind of trying to set up right now. I used it at a previous company and it was pretty useful, but not in a Kubernetes type of infrastructure. So.
Okay. I mean, I think that the common workflow that you're going to find across all of this is that your CI will always react to, like, let's say, a specific branch, right? And that will kick off this build process. Whether that's Container Builder, Jenkins, Circle CI, CodeShip, they all have triggers, right? It's just a webhook that kicks off building this Docker image. Some of them you can actually like build in so this build pipeline has stages. And these stages allow you basically to do like Docker build. They will allow you to run tests on this local Docker container before pushing it to a registry. So you can, they'll run that Docker container locally and then issue maybe some HTTP requests or something like that. And then it'll kick it off to this container image. And so, container registry. So that's where your artifact is living. And this is something that's not Kubernetes aware, right? And so that's where in your continuous deployment or continuous delivery, you need to, you're actually invoking and interacting with the Kubernetes API, right? And so this whole CI/CD pipeline could be one whole CodeShip workflow where it's actually generating a lot of the YAML for you, which I think CodeShip does. CodeShip has a really nice UI.
Yeah.
I haven't used it myself. So some of the things that you're seeing that Chris was talking about, right? Whether it's like defining a service, right? Because let's like, you know, in Kubernetes, a container image doesn't live isolated, right? It may need config maps like configuration or environment variables or credentials and secrets that need to propagate, and it needs to be deployed together in order for it to function as service. And so, you know, a lot of these pipelines will allow you kind of to define that in their interface, or things like Jenkins will actually have you kind of generate that yourself. So it really, you know, there's Jenkins files are kind of just like Swiss Army knives. They'll just do everything.
Exactly.
You're just wrapping shell scripts, right?
I think everybody used Jenkins in the past, which is super powerful, but you know, exactly to make it easier, and maybe sometimes, you know, the Swiss Army knife is overkill. So Scaffold, is that an internal Google product, or?
It's an open source actually piece that's part of the Kubernetes
Oh, I see.
project. So if you just say Kubernetes Scaffold, you'll see the GitHub repo, and it talks about it.
Yeah.
And it kind of overlaps through this again, and you can mix and match a lot of these things, right? So you can define through your process if you want to use CodeShip, and then you can link that back into the container builder. You can have Scaffold use it. The Scaffold is at the basic level, it's just a I don't know if you guys, for example, familiar with Node.js and NodeMon, which just monitors, and if there's a change in source code, and then it deflects that and it runs again. So you can look at it as a more elaborate version of that, in the sense that you're locally making changes, right? And then it recognizes the change and the file is saved, and then it automates the build, push, deploy process, or any subset of that, which is the important part, because you might want to do a build and push, but not necessarily have also automate the deploy portion, right? So it can be constantly building containers and then push it, and then pushing it into the container builder. You can have flags that now goes into work and says, okay, what's the next step? And the next step could be that, oh, I got to do my integration testing. I got to do my unit testing, my regression testing. And all of that can be passed back into the CodeShip if you want, right? You know what I mean? So because there's a lot of tools, right? You can, ideally, you want to stick to minimum number of them. And then you can define what part you want to do, right?
Exactly. I mean, this is exactly why I think I want to kind of figure out, you know, what your guys' recommendations are. Since I absolutely want to avoid having.
There's those parts. Yeah, there's parts in terms of running Kubernetes itself and GKE that we can talk about more mature best practices. And then there's parts like this CI/CD that there's a lot of solutions, and it's only accelerating in the number of new solutions. So we can talk about different tools and what they achieve, but there's not necessarily one best way to do things, and that's something that's just being learned and figured out. So for example, and you can, through the documentation, you can kind of see what they're pushing as a best scenario use case. So again, for scaffolding, you see they talk about quite a bit about, especially if you're testing something locally and you got Minikube running and your own cluster, and you're just making changes to the code, and then you wanted to just rebuild the container and then push it. It doesn't have to be locally, but that's a really good use case for it. But it's completely pluggable, actually, what deploy means for scaffold. Does it mean deploy locally to your Minikube, or you're actually going to the dev and test environment in your cluster in GKE or any other? It doesn't have to be Google Cloud Platform at all. It's can be plugged into.
Which one of these on the CD side would you say integrates best with Kubernetes? So it has this awareness and, you know, helps you manage, I don't know, access keys or what have you.
I mean, Kubernetes doesn't really care where the container
it comes from.
You have a container and you want to do deployment, but from deployment and configuration perspective.
So part of the consideration is how you do your development and staging environments. So some people will use namespaces in the same cluster to actually segment out development and staging and then production, right? So all of these live in the same cluster, and you're just defining, you're deploying to specific namespaces first before deploying into, let's say, production. And you're running your tests, and you're clamping down your staging and development to, because at namespaces you can create resource quotas. So I guess I did. So these can like deploy into a single cluster. Here I have my control plane. I have specific nodes, and then we can just target run. So let's say dev staging. Let's say each of these boxes are namespaces. We can run tests here, and then deploy here, and create quotas. So as far as like, I think most tools will be pretty good at this paradigm, right? As far as being able to target one cluster, different namespaces. I think it gets a little more complex when you want to say, let's have a cluster for development, and then maybe a cluster for staging. Now I want to like, we can talk through some of the advantages of segmenting them by cluster rather than by namespaces in one cluster. But I think as far as like, if I'm separating all of these out by cluster, Spinnaker, from my experience, it makes it really easy to target multiple clusters in a given pipeline. I think it gets a little more difficult handling kube config and things like that in, let's say, like a Jenkins file, right? Because now you're having to configure access to 3 different clusters. And again, it just feels kind of like a Swiss Army knife. I think CodeShip is probably good at this, although again, I haven't looked at it. CodeShip, the thing about that versus Spinnaker is really like, CodeShip is just, it's SaaS, right? You're paying on like build hours. You're not having, like Spinnaker, so far as I know, you're gonna have to like install this somewhere, right? And so there are components in Spinnaker, there's an architecture, there's Redis, there's other components I forget the names of, but you ultimately are responsible for that, right? So it's like, that brings into question, like, what are your priorities? Is it really just like get the build out, be able to have some complex like deployment strategies, whether it's across clusters or across namespaces? CodeShip might be right for you, right? So I think if your priority is like least management possible, SaaS solutions become a lot more viable in this.
Exactly. Yeah. No, that's definitely a priority.
Yeah. So
no,
again, I think Nima will touch on, because Scaffold lives in a kind of a different space, but like, CodeShip really is, it sounds like you're already well familiar with Jenkins. Sound like that might not be the path. We have like a few patterns covered in like this slide deck, but it's like things like, we'll see people adopt Jenkins because it's what they're used to. It's really,
flexible.
They don't want to change their existing workflow. Again, if you're starting something that new.
I think I'm sticking with CodeShip for now, again, because I have a little bit of experience with it. I like it, but I'm going to explore more. But I definitely also going to check Spinnaker and maybe Scaffold just to get an idea.
So we definitely have like best practice or canonical ways of like deploying Spinnaker that are documented. So like,
great.
I can always walk through that tutorial.
Yeah.
The interesting thing here is I think Chris alluded to it, there's Helm as well. That sort of lives as this kind of.
I read about that.
Have you
Yeah.
all heard of Helm?
Well, the funny thing is we have like an internal, project names that I just made up, all based on Lord of the Rings. So I was like, let me use Helm and Deep, Helm's Deep, yeah. And then I coincidentally stumbled across this as we're looking at the Kubernetes
Do you have more
documentation.
Lord of the Rings stuff, or Helm's Deep is Lord of the Rings, right?
Yeah.
Okay. Yeah.
I mean, in the past we use all kinds of things, Star Wars. I think at some company we used vegetables, which was weird. But
well, that makes sense. Like
whatever works.
Yeah. Yeah, I had a customer who named everything after butlers. Famous butlers. It was really.
Wow.
I'm not sure. Like there's like the Addams Family butler. There was like.
Whatever works.
Butler from like there. Yeah, the Alfred was one of them. Poole, which is like some British butler they're kind of famous. The guy was British. Anyway, so Helm, interestingly enough, just want to give some context of what people are doing outside of just building Docker containers here. Is so ultimately in your CI, you're generating, and guys keep me honest here, but like you're generating a lot of the YAML files, right? That will allow you to deploy these, right? And so Helm allows you to group a bunch of Kubernetes resources together. So this could be service, a couple deployments. And then let's say you want to store like configuration environment variables in an object that's called config map. And again, we didn't cover all of the kind of objects that exist in Kubernetes, but basically all of these may need to be deployed together in order for this stuff to work, right? And so Helm will allow you to package multiple kind of YAML files together. These are all YAMLs, and then deploy them at, all at once. And so Helm will often integrate with tools like, let's say, Jenkins. You can use Jenkins to, as part of a stage, install this entire little box here, right? Rather than having to kind of figure out natively, like, well, what's the dependency that I have for, let's say, food and bar to work, right? Instead, you can group them in a Helm chart and then deploy them all together. And then, so Helm is like a client that you'd invoke in like a Jenkins pipeline or a container builder pipeline, and then, it'll do like Helm install and it'll deploy all these things at the same time. So Helm is not really a CI or CD tool, but it is an effective way of packaging up multiple artifacts together. That could be your Docker, the YAMLs pointing to your Docker containers, but also, again, some of this ancillary stuff that really needs to be deployed together in order for it to function.
Okay.
Because then if you're trying to like package these up together, and let's say if config map doesn't go with like this deployment or this deployment, then you could have bad config and then errors in your application.
I would say like 6 months ago, Spinnaker, well, even recently Scaffold, like those are built with Kubernetes in mind, right? Jenkins was not built with that.
Right.
But the space is evolving, right? So like Jenkins came out with Jenkins X, right? To try and bridge that gap. So all of these tools are doing very different things to be more Kubernetes aware.
So it would be interesting to see if CodeShip integrates with Helm. I suspect it does, just because it's very Kubernetes focused, and so. But that's just one thing to, as a recommendation if you're looking to templatize. So like you can populate your YAML with like let's say parameters that's just a template, and then you can pass in values to populate those parameters in the YAML.
That could be pretty powerful, yeah.
And then there's like ways to have a registry for Helm charts too, and there's ways to do that on top of Google Cloud Storage.
Helm charts are what?
So just the grouping of those resources.
Just more names that throw at you.
Sure.
Or the
Just
confusion.
the template.
Okay, yeah.
So is that mostly what we want to cover for CI/CD?
I think so. From the
Show
timing,
like yeah.
I think from timing we should move to GKE. I would say as you go down Kubernetes CI/CD, if you're interested in learning more about how does CodeShip work with this, or you actually want to know more about, well, CodeShip is really good for deploy, but we have great tools that do the CI portion, and we talked about that container builder. I'm a big fan of that, like having something else do builds for you, and bin packing really well. We have lots of good practices around that. So just as you explore that space, we can continue the conversation.
Absolutely. And Andreas, who joined, I think he might have dropped off again because again, he's in a different time zone. But one of his first tasks is to do that, exploration. So hopefully in the next week or two. Well, yeah, let's see. But we have some better insights, and then we can always come back and follow up if there's more. Appreciate that.
Yeah.
Great.
All right.
Quick check, because we're halfway through. Do you want to do like a small break, or we don't want to push through? It's been an hour and a half.
Do you want to take over from me, or do you want to take?
We can do a 5-minute maybe.
Yeah, maybe 5 minutes.
5-minute break.
Thanks.
Great.
Where's the restroom? Oh, I can.
Yeah.
The loss.
Oh, is there a power bank?
Oh, the little icons, Chris. I'm saying all the little icons for the rolling updates.
Oh.
No, we don't need to. I was just.
I want to show it. Wasn't there another one in there? This is unique. Usually it's companies like come with like, this is what we do. It's like hard to move.
I know. It's a lot more fun when greenfield. It's like, oh,
Yeah. I think it's rare, at least for me, to talk to
spend
a
more
team.
time
It's
on
like,
cool things to do.
we
rather
can
than,
choose from
oh,
fresh.
maybe-
Yeah.
It's almost always the case you go in and they're like, we use Jenkins for everything.
Yeah,
It's like,
yeah,
like
yeah.
moving that is going to be.
And so we're just like, well, it
okay.
plugs in with Kubernetes.
Yeah.
And then one thing that's pretty cool, while we're on break is like, so even on the CI/CD things, you're controlling what gets deployed into Kubernetes, but then there are some native strategies that Kubernetes will take. So by default, like you can have rolling updates. So if a deployment is changed, you deploy out a new version. You can have Kubernetes kind of have like a max surge, max unavailable paradigm where it'll spin one down or spin one up of version 2, spin one down of version 1, and then continue that until it's all version 2.
Nice. Yeah.
And that's just something that, again, you just define in your YAML,
Okay.
and they'll kick off a rolling update for you. You can roll that back to, like, there's a lot of stuff that is just native to Kubernetes yourself. Like, even if you're just to like, I'm the client, I'm just kubectl, like using the command line to do these deployments, you still get all of these like built-in, strategies to have version 1 and version 2 like roll back.
Right. I mean, a little of that. I mean, we saw in some intro videos, and Kazim and Ed and I actually joined this GCP. What was it called? Onboarding.
Onboard. Oh yeah.
In
Nice.
Santa Clara, which was more high level, right? Intro,
Yeah.
but it was pretty neat because I think they had a demo of the Kubernetes, like, once container or pods fail, just automatically spawns them up again. So it's kind of
Yeah, I think I gave that demo. I was in Santa Clara. Yeah.
Oh, okay.
Yeah, this was just like a month ago, right, or so.
Yeah. Oh, I'm sorry. We're sitting far back, so.
And last.
Anthony is the face of Google Cloud now.
Yeah.
Oh, did we talk, Anthony, afterwards?
Man.
Yeah, I'm just thinking now. You're mentioning it. I might have come up. I was the guy asking about IAM, the role.
Yeah. Oh yeah. No, we definitely met.
Yeah,
It's
cool.
crazy.
It's a small valley. I see
It is a
this
small valley.
again and again.
It's a small city. I always say it's a small city, but it's just a small Bay Area.
It's No, I've been in the Bay for 20 years now or something, and starting in the .com
Sure.
boom, and I think it's a small valley because this happens to me more frequently, where you suddenly it's like, hey, I know you from XYZ. So
Yeah, it's very true.
yeah, so I think this is a really great opportunity because for me it's kind of a similar experience. It's rare that you have the opportunity to build something really from scratch.
Yeah, that is pretty cool.
I don't think I've done it once at a startup, but that was kind of a very different space, like a simple web application for consumer facing.
And I'd even say Kubernetes now versus Kubernetes a year ago right now is the time where it's like all the new releases. I mean, it's nothing exciting because a lot of the kind of, well, is this production ready? Those things have been addressed already. Like a year ago, we were still working on like RBAC.
Yeah,
That was just in like beta or alpha or something like that, but
you know,
it's much more mature
right.
now, right? So now I feel like is a good time to.
I joined the company, and as last year, and as I was or end of last year, and as I was kind of contemplating the new architecture, my mind was set on AWS. I didn't have any second question, and then I had some discussions with some peers who told me about GCP, and I was like, no, I looked into Google Cloud 2 years ago. It was crap. I mean, there was nothing there. It kind of even compare, and they're like, no, look again. This is, how we are here today. So,
You know what a lot of people look at Amazon too for Kubernetes, and because they announced their whole managed thing. I think it's probably coming out of preview in summertime, something like that. But it's like, I think our investment in Kubernetes, it's staggering when I say, okay, well, Kubernetes engine, it went into GA in August 2015, right? I mean, that's by the time Amazon gets to a point where it's public beta or GA, like Kubernetes engine will have been GA for almost 3 years by that.
right.
So it's like, there are a lot of places where I'm like, okay, sometimes you're just like checkboxing between spec on different clouds, but I firmly believe that Kubernetes engine is like a step function above like where Azure and Amazon are at, as far as a managed Kubernetes offering. So yeah, it is pretty crazy though. A couple of years ago.
Yeah, I think just in the last year. I mean, even on this IAM stuff, because I've been playing with it quite a bit, the UI has changed probably 3 times since January. I mean, I'm not kidding you. Suddenly I'm like, wait a second, where's the permission drop down? And then, it moved somewhere else. It's kind of, you guys are moving fast.
Yeah.
Cool.
Anything else?
Yep.
So this is, I guess, yet another level of abstraction and management, right? So Kubernetes is itself orchestration and management. And this is another level, I guess, with Kubernetes engine is like, okay, as you saw with the cool sequence diagram that Chris was showing, there's a lot of stuff that happens that Kubernetes does for you, but then you also know that there's all these components to Kubernetes itself that you have to manage. So we covered that a little bit as well in terms of every single piece that you have to run, which unless you have a whole massive DevOps team, may not be a problem and you want to be more hands-on, but more and more you'll realize that, you don't necessarily have to deal with this, right? So, I mean, that's why Google Kubernetes engine is very much, can we do a really good job with managing Kubernetes clusters for you? And that comes down to the 2 categories of, what Kubernetes does and what the challenges are is, one is running Kubernetes itself from an administrator perspective. One is actually using it from a developer's perspective, right? So from a managed system, you kind of want to address both sides and what you can do. So some examples, right? The provisioning and the networking that Chris whiteboarded, bootstrapping the cluster services and resiliency and so on and so forth. And some of these features that's provided in GKE is, hey, this is what we're going to provide for a managed Kubernetes system. And a lot of it also is naturally intertwined as part of GCP and how networking in GCP works and how resiliency and scaling in GCP works. So we'll talk about certain features that are not necessarily, we're not necessarily built for GKE. It's just part of how scaling, for example, and so on and so forth. But yeah, so, abstraction over infrastructure. And then, the second part from running it is actually using it, right? Deploying applications. And so to start, if you go ahead and if you have a Gmail account or any console of GCP, you go and you run that gcloud container clusters create and you give it a name. And it does everything and creates this cluster for you with 3 nodes, I believe, by default in central region somewhere. And it's all up and running, and you can start within a couple of minutes. You can start, playing with it. So I think that right there will give you kind of an idea of, this is all it took to get a whole cluster running and start playing with it in order to explore and learn what the system is.
So at this point, what is exactly running? Because you didn't have.
So it starts up a cluster in whatever project that you're set to. So it depends if you do this, I guess, from the UI or the command line, right? But from the UI, you're already selected project. From command line, you have a set configuration that's currently in. So that's a project in a specific region and so on and so forth. And then you say, hey, create a cluster for me. And there's tons of course, arguments that you can do, which corresponds to all the different options that you have in UI.
Okay.
Or you can just have this, and then it does a default. And you can see from default, again, it's like a 3-node cluster.
Oh, I see.
And it has a N1 standard machine types, I believe. So, chooses standard machine type, chooses kind of standard naming, and then I think it's central 1A or something in one of those zones. It does. But actually, we can, let me just quickly show if you, so this is your UI, right? And if you go create a cluster here, all the options that you're going to see here are the kind of things that you obviously, the flags you can do. And if it's easier for you rather than reading a reference, and many pages of many flags, you can choose everything you want here, and you can just click this link at the bottom, and it tells you in command line what that equals to. So obviously, at some point, you want to make it programmatic, you want to make it automatic, and or you can just the JSON equivalent. So this is an easy shortcut to
That's great, yeah.
figure out. It's one of my favorite features. The only reason for me to use the UI, honestly.
Actually, yeah, it's really nice.
No, it is.
But seeing the workloads is cool.
Yeah. So, but that's all it takes to get like a sandbox up and running, right? Actually,
And it says minutes, so I mean, how long
it 2 to 3 minutes, I would say.
as a baseline? So depending on how many nodes.
Yeah. So this particular thing, obviously, if
Yeah, sure.
if you're creating something with 200 nodes, so it'll take. But the I actually haven't tested to see with 100 nodes how long it takes. I don't think the variation is that much more because a lot
it's
of
not
this is
bad.
about setting up the networking and the master, and for those it doesn't make that much
Our
of a
VM
difference.
startup time is actually really, I would say, really fast.
Slower.
Like, perhaps compared to other. So the most of I think the time is spent a lot on what Nima will talk about, all the components that it's trying to configure, and also make sure the worker actually talks to the master, that's set up, everything's running. I think all that stuff, the bootstrapping, it's waiting for that to complete, I think, for the most part.
Yeah, I mean, timing might be pretty crucial for us. I don't know if you had some progress on that end, but as part of our bioinformatics pipeline processing, there is one stage in that process that we need to parallelize fairly aggressively with hundreds, if not thousands, of engines running in parallel for a couple of minutes. And did you have any updates on that? But I think in terms of this run-up time, this getting this spawned out, it took.
Is there necessarily a requirement for you to be creating and destroying clusters in
I don't
this
think it was
work?
clusters. Oh, was it a cluster or what was it?
Yeah, so we're using the pipelines API.
Oh, okay.
Yeah, and so that seems to be not something that's managed by Kubernetes. Yeah, so it's basically like Cromwell starts as an orchestration agent, and it manages the setup and teardown of VMs. So I haven't actually. I just started taking a look at the timings this morning.
Yeah.
But there's some amount of time that's being spent pulling the image, right, and then spinning up a VM with that image, and then the teardown.
So I'm not sure if this pipeline API is utilizing
Yeah,
Kubernetes
so it's not Kubernetes underneath the hood. That's
Okay.
just, and that might be what you're seeing is actual, and I don't know if we're spinning up VMs and then deploying containers on top of them, but ultimately it's not Kubernetes under the hood. And the reason that's important is, so in Kubernetes, part of what you may want to do is, I forget what the spec is, but there's this field where you can have images be pulled locally, not always pulled from the registry, which is, by order of magnitude improves boot time.
Yeah.
And so then in Kubernetes, like we talked about deployments, that's one way of running like stateless workloads. But if you have like run to completion types of tasks that you're packing up in Docker, you can use what's called a Kubernetes job. And so that's just a different type of way of deploying pods. And so you can define parallelism in that YAML, much like you would in the pipelines API. I think it also takes YAML, right? So it looks very similar, but I think there's a lot more, that's one of the things about Kubernetes that, that's an advantage over more black box type of solutions is there are ways to kind of improve, let's say, cold boot time, if that's a concern. You'll want to like kind of have that image, if it's not constantly changing, already on the Kubernetes cluster itself,
might be a good
as
plan.
opposed to having to pull that every single time. So
It's called a pull if not present. I
there you
think. And then very importantly though, you should tag the image.
Yes.
If you don't tag, it defaults to latest, and that basically means pull every single time.
I see.
So you're gonna see a huge like just slow down. So that's, as long as you do that, you should get it.
Cool.
Yeah, man.
And talking about image and containers, how you're building and what the base of that itself, there's optimization to be
Oh yeah, that too.
done there itself.
Yeah.
What size is
Mm.
so not sure what you guys using, but we can have sessions to talk about.
Yeah, we can take that
Yeah.
later. But
Um,
okay, that's good to know.
So the last line here is one thing that we're quite proud of is usually within 1 week of the release of the Kubernetes group schedule, you have that in GKE available. So typically the timeline to have the latest Kubernetes up and running in GKE. So I guess we could kind of go through some of these. So we do have there's a couple of things. One is at this point regarding availability, we have zonal and regional setups, and I think we have a So we have this one is a multi-zone cluster, and I thought we had a
Probably.
I thought we had a slide. Anyways, the ones where you are replicating across zones, your node pools, versus the ones that you also are replicating your master as well through zones within a chosen region. So it could be between 2 to 4 kind of replication in order to give you a higher replication. So your SLA will naturally go up if you're using regional with higher replication.
So is that something we can?
So it's something you just simply
Select.
choose, yeah.
I see.
And I can show you that again. For example, oh, it's actually up here. Yeah. So in location, you can choose, zonal versus regional,
Mhm.
which is a newer one, which replicates your master across multiple zones within that region.
Yeah, I don't know if we call it on the slides, but something really, I guess, important in the construct of how this works. The master nodes are actual, to my knowledge, virtual machines that are in a separate Google project. So it's actually a GCP project, and it's managed by Google that you don't have access to.
Mm.
So they actually are there.
Mhm.
What you see in your project is everything down from the master, right? That pool.
Mhm.
You see all of your worker machines.
Right.
The master just shows up as an endpoint.
Yeah.
And so what Nima is saying is, if you do the zonal, like that master machine is in one zone, where regional, it literally shows up in 3 separate zones.
Yeah.
I don't think you can control the zones that it shows up in, but it spans 3 zones in that region.
I think it.
It'll just be all the zones in the region.
All the zones. In
The only
the
place it's weird is central, because there's 4.
It's only 3, right? I mean, yeah. But yeah. It's going to be highly available, and that's where the SLA comes in.
Mm.
One is 9995, and the other is 3 nines.
So if you want to have, you showed regional and zonal cluster, but if you want to have, let's say, global for some reason, then node pool is the way to go, where you can have some nodes from one region and some nodes from another region. You can combine them in one node pool.
within within the cluster, within the same cluster, yes. But if you want to go across regions, then you're talking about different clusters.
So you cannot have a cluster across regions, one cluster across 2 regions.
No, and that'd
No.
probably be an anti-pattern, because part of the advantage of having them in the same region is a low latency if we're having multiple microservices communicating.
Right.
If you're having a cluster span multiple regions, so 1, you can't do it in GKE, but 2, now you're getting all the egress charges.
I think I saw a diagram in one of the slides where you have node pool, and in the node pool you have one node from one region. And
So that's across different zones in the same region.
oh, okay.
Yeah, so US Central.
Might have been this one, yeah.
Yeah.
Yeah, so it's all US Central,
Just
right?
different
Same
zones.
region,
Yeah.
just different zones, like A and B.
Yeah. And
So what about scenario like where you want to keep European customers' data in Europe versus US, right? So you want to have your application available in 2 different regions. So that's a pattern for 2 different clusters, or?
So it's a pattern for two different clusters, and then what you do is you keep your two different clusters stateless, and then you start to ask yourself how you manage
The data.
a database, like globally. Like, are you handling replication between two different data stores, each, or are they just storing different, like, will they just be different databases, right? If like you have European data. Spanner is something that people will investigate in this type of scenario, as it's kind of like that.
But how would cluster management work then? Because we want to have same application deployed for both regions.
Yeah, so that's something where you can handle that in your pipeline by just targeting two different clusters, right? Deploying the same application.
I would say, I don't know if you're gonna talk about it, but the node pool concept, we're gonna get to that, or the node pool concept is specific to GKE. I think it's a pretty important one. So in your cluster, you may have a variety of different types of machines that make up that cluster. So a very simple example is CPU machines, but you might have some machines that have GPUs attached. And so what you're seeing here is the ability to create what's called different node pools, which is basically a way of saying like a group of machines that share a characteristic. And so by doing that, you can get a little bit more specific when you actually deploy your stuff to be like, well, this is a workload that needs a GPU. So go to my GPU node pool. Others include preemptible virtual machines. So if you have preemptible virtual machines are essentially like borrowed virtual machines from Google. We give it to you for 24 hours, super cheap. It's like excess capacity that we sell on a daily basis. It has no like SLA, right? But basically, let's say you have like this giant batch job and you want that excess capacity to try and parallelize your stuff as fast as possible. You could create like a preemptible pool, right? And just say, give me as much preemptible capacity as I need, and then point your job at that, right? So that concept of node pool is really important because you can kind of group your machines, but also very importantly, if you create a multi-zone cluster, every pool gets replicated in every zone.
Oh, okay.
So I think it's also in the lab, like, so if you have like two pools and you say, well, each has 3 machines and that's 6 machines, and you like create another multi-zone cluster, like the number of machines that you have will actually double, right? There's that concept.
Yeah, and then from the pod side, there's so the way you would kind of direct pods to go to, like, let's say this special hardware that Chris was talking about, right? That it maybe makes up a portion of your cluster's resources. It's as simple as just attaching metadata, both to the nodes themselves. So it's just a key value pair. And then in that YAML file that you're writing, it's called basically node select or node affinity. You can give your applications that same key value pair, and then the scheduler will see that and be like, all right, direct applications to this group of nodes. So
you can set up your own node template or pool template, or?
Yes. So there are ways to label nodes as a whole, like a node pool. So multiple nodes there.
And you can configure like CPU, memory.
Yes. Yeah. For each of the node
machine
pools.
type, CPU, memory, and then you define. So you give it that, let's say, whether it's command line or API, and then you also say now number of nodes, right? Whatever you define. So you define one type and you say 10 of these, and that becomes your pool. Right?
Cool. The last thing that's pretty cool is that by default, it will use some of these labels on the nodes. Like, so those labels that come by default, you don't have to do anything, are like denoting what zone it's in. And so the scheduler will actually be like, oh, let me actually distribute this across all the multiple zones available, just for high availability purposes, right? Because that's why you'd want it in the first place. It's like its own segmented failure domain. So if I have 3 replicas and I have 3 zones in my cluster, Kubernetes will automatically spec, right? So there's some stuff that gives you like the ability of having this spread without having to like ask for it.
So you don't have to define that.
So that's like a default characteristic. You can alter it by directing it, let's say, to a certain node pool or something like that. But if you look at the scheduler code, like, it's actually something that in a multi-zonal situation, it'll look at the different zones available and then say, oh, I can distribute these.
Cool. Yeah.
That's right. So that's pretty cool.
Yeah.
There's like some powerful stuff that you don't.
Yeah,
it's just built into it.
Okay.
So I guess we talked about preemptables. Yeah, and then these are the different components that come with GKE right off the bat, and you can see a lot of these matches to the different components that was part of Kubernetes, right? And these are the things that we manage. You got your DNSs, the autoscaler, you have the Fluent DN hipster for logging and monitoring. And container optimized OS, which is the default, and then there's Ubuntu.
That's actually pretty
image as well.
important. If you have a custom virtual machine image that you need to use, I don't think we don't support that today with GKE. So the default is the container optimized OS. I think the parallel is Chrome OS is a wrapper around Chrome. The container optimized OS is a wrapper around the container runtime. So it's like a very narrow, really slimmed down virtual machine image just to run containers really effectively.
Mm-hmm.
But if you want more tooling, because you want to do more apt-get install and stuff like that, you will have to probably use Ubuntu. And then if for some reason you need a custom virtual machine image, then you're kind of outside that world. So just keep that in mind.
Yeah. So actually, so if I understand that correctly, then the slimmed down version just doesn't come with typical things like Python, Java on it, or
it does. Let's see. So it comes with something called a toolbox. So if you want to do your base CLI commands and stuff, you can kind of inspect your containers that way. It actually runs those into a container. So if you want to do a ping, it'll run it in a container. Python and Java, though, that's more in your container image yourself. You can put whatever you want in your image to run your stuff.
Okay.
This is more to inspect the state of your node and also your containers. Yeah.
So, here's a general kind of list of different things and challenges, from deployment to running, from managing components, encryption, rolling out updates, uptime, bootstrapping TLS, so on and so forth. And again, the kind of list of the things that being managed for you. And it's being managed by Google SREs, right? We have massive teams of SREs that, it's the same pool that, because we obviously also use GKE quite a bit, and the way we run containers, and this is the same plane with the same network, with the same security and the same SREs that are protecting, our Gmail containers as well as the container that you're running on your GKE, right? So if you like us to be your SRE, then that's the point of using this. So there are some considerations, and some of this, I guess we'll have to update now. But basically, till recently, it used to be that your master would always have a public IP, and then you would communicate through that. We have an option now, in is it alpha or beta? I guess beta. Oh, okay. So it's further along, that you can have a completely private cluster, that all the IPs are internal and the communication is purely internal. So you no longer have to deal with securing an external IP if you're not necessarily using that cluster for anything IP external facing. So we had a bunch of features when it's external in terms of protecting your cluster. So IP rotation, obfuscation of the master location, rotating the SSL certificates, and so on and so forth. Oh yes, and the whitelisting of IPs. But yeah, this is in the documentation now. You can see that it's also another option as part of creation, that now you can do a private cluster. So it's purely just internal and private IPs, which is great initially as you guys are kind of running the system and bringing it up and testing it. You don't have to worry about, right off the bat, this is exposed and I have to kind of protect it.
Right. Would that make sense in an architecture to have, one private, one public cluster?
I guess it depends on
for internal services versus.
That's actually a good question.
So I guess, I mean,
Do you know if you can expose a service externally on a private cluster? Is that, I don't think that's possible.
maybe
Unless
it's
you
through shared
VPN.
VPC.
This is a private cluster. It has no public IP, right? So
Not directly, but
I think the concept with the pattern around the private cluster generally happens to be more like you have a corporate network or an on-prem environment, and you're VPNing into the private cluster, and over that VPN, you're trying to hit a private service, as opposed to like a public internet-facing service. So in that sense, you might be right. You might have a private cluster that's like just internal dev staging, perhaps, but your production cluster might need public IPs because you need to expose
almost, almost
to the external world.
To communicate between private and public cluster, is there any specific handling, or is that fully kind of isolated, or?
The communication between, so clusters by themselves are pretty separate. Like if they happen to be on the same network, you could obviously ping the virtual machine nodes, assuming you had the firewalls open. But likely what you'll do is the same thing that you would do to any external user. You create a load balancer or something, whether it's an internal load balancer or an external load balancer, and you go through those two things, generally speaking.
Yeah, okay. Maybe could be interesting, but cool. Good to know.
So you're since the master control plane is fully managed by us, we do the upgrades. You can kind of trigger the upgrade to happen earlier than when it's scheduled to, and you can also kind of choose the timeline of the service upgrade time in case you have, traffic patterns that you want to avoid, for example, to, hey, if you're gonna do the upgrade to the master, do it 2 a.m., 6 a.m., GMT -5. There's something to be thought about it if you have a regional cluster that's now your master has HA, so because it's replicated across the zone, then this becomes less and less of an issue because you practically have no downtime because not all 3 masters will go down at the same time, of course. And of course, something that you might have noticed by now, learning about Kubernetes is your master going down doesn't actually stop your system or anything. It's just that your API communication is disconnected, but the pods and everything is working till it's back up, and then you would get your communication back, right? So
does it automatically restore the master if it goes down?
Well, I mean, for GKE, yes.
Yeah.
But I meant more in general, just Kubernetes itself.
Sure.
If you have a masters and you have orchestrate the whole system up and running, if the master goes away, all of a sudden, nothing that's already up and running will stop working for that state, of course. Now, as soon as something goes down, then you no longer have the monitoring and all that. So we have, so we also have, so the master upgrade is managed by us, and it's not optional. You have some, you can trigger it or you can choose Windows, but it will happen. You can also opt in to have your nodes upgraded by us as well. By default, it's not doing that. So if you don't have it enabled and we're not upgrading it, we always recommend to stay within 2-point releases. So if your master is 1.9, then don't fall behind.
The node is just like an infrastructure code around it, or what?
So your worker nodes, right?
Mhm.
You have the master, and then you have your
Just that
in the pools, and the nodes. Yeah, those are not being. It's up to you if you want us to actually upgrade those, or you're gonna work that into your CI/CD system and the upgrading of the kind of the worker.
How much do we have to worry about like backwards compatibility or any kind of these issues? I mean, should we just enable it? And
yeah, so that goes back to Kubernetes itself, right? And do we have an SLA or does Kubernetes has an SLA, is it 2 to 3 point releases in terms of backward compatibility?
Oh, you mean like a guarantee on backwards compatibility?
Yeah, because I mean,
I'm not sure about that.
I would say it's
Maybe it's not an
feature
issue because
features.
hopefully we're not touching much unless there may
I
be
would
some
say even a year
APIs.
ago might have been a bigger issue than now because it's
Yeah,
more
more
mature.
stable.
But
But still-
because certain things were being, I know a lot less of them now, but between last year to this year, there's several concepts in Kubernetes that were deprecated and replaced with new ways that they're still kind of functional, but are going away.
Well, so anything that's promoted in Kubernetes to GA should always be stable, unless we broke that paradigm. So for example, the deployment, when it gets graduated into GA, it means this will be supported in production going forward. There are some products that are alpha and beta. Those are the ones that tend to be like, we don't know for sure if this will graduate,
Right.
so it may disappear.
I think if it makes, so you're talking about Kubernetes objects and
Yeah.
resources. Yeah, if it's in beta, it's almost certain like it's going to stable, right? But if alpha is where you will see like name changes, API changes, things like that. When it hits beta, it's like, for instance, pods and deployments were in beta for like a year, but they were being used in production. Like I think Kubernetes has the community is very interesting. Like if it's in beta, it's relatively stable. And
Yeah, no, I mean, that makes sense. I'm just wondering, like, from a maintenance point of view, you know, how much we need to, if we enable the auto upgrade, right? How much we have to pay attention to possibly things failing on our end.
yeah, so some of the stuff you'll really have to consider is the scale of the node. So upgrading happens node pool by node pool. And the interesting part is it goes, the flow is it'll drain, or does it, well, so it basically drains all the applications that are running on the node. And so if those aren't run by a deployment or like a controller of some type, like those are gone, right? And then even then, like if you have a small node pool, taking out one node that was maybe a third of your resources, right? That will significantly affect like everything that was running on that one node now has to be rescheduled on the two.
Right.
So like you know, one, you'll want a controller around the number of replicas, and two, you'll want to be wary of how much headroom you have as workloads get rescheduled and shuffled around during the upgrade process. For the most part, it should be like a no-op, right? If it's something where you click it, like it'll go through the process. But those are some of the considerations you'll have to take into mind.
Is there a way to roll back in case something goes wrong?
You can downgrade, but it goes to the same disruptive turn off
Sure, yeah.
cycle.
Yeah.
And
even then, all the applications are, I mean, the pods have been rescheduled already by that point. So there's no way to like get that old, you know, the old host image and then deploy the old pods. Right?
This is my personal plug. I've worked with customers, and Anthony's talked about different paradigms. I've seen what works really well is to have the production clusters separate. So what my customers have done is they upgrade their dev environment first, and they do all the right things. They give pod disruption budgets to try to ensure the service is alive during the upgrade. But if anything goes wrong, they catch that before they even try it on the production cluster.
That's what I'm thinking.
And they've actually
makes a lot of
they've
sense.
done that like at least 3 times, that they've caught things like that. That's a very powerful paradigm.
I agree with that.
If you so just keep, again, different options, different ways of doing it.
But earlier you mentioned people use namespace, right, for separating the environments.
Yeah, that's an option.
Right.
Yeah, but I don't think I don't think you can upgrade by namespace.
Yeah.
So that's where the slight trickiness is. So
Yeah. Like there's ways to clamp down namespaces from a resource perspective, right? So that, you know, dev and staging aren't eating up a ton of CPU or whatever in your actual production cluster. But ultimately, from an upgrading perspective, if that's a concern, yeah, it's prudent to just have a QA or staging cluster or something like that.
I don't think it's going to be a big issue, but again, since we're building it from scratch, we might as well try to put in these
Yeah, I would look at the tool that you move forward with CI/CD and just see what it looks like to deploy into multiple clusters.
True, yeah.
So look at CodeFresh if that's something, or I'm sorry, CodeShip if you're well familiar with it and you want to move forward with that.
Yeah.
See how it handles multiple targets as far as clusters.
Yeah.
I imagine it's not difficult, but yeah, look at that first.
Yeah, as far as the backward compatibility, just keeping an eye on the release notes of the next, whatever new release of Kubernetes is coming out, to see if there's big changes that are actually potentially could break something. That I would say that would be your first kind of, and from that point on, then you have basically 3 releases, right? If you have 1.6, you just keep track of 1.7, 8, and 9, and by the time you get to 9 and you see, oh, there's breaking changes coming, then you know that by the time 9 is GA and we can upgrade, then your worker nodes need to be 1.7. So then you just pay more attention to, you go back and look at 1.6, 1.7, and that's kind of your first pass of, doesn't look like anything is gonna, and then you
No, exactly.
start to test.
Okay.
Yeah. So in terms of kind of categories of what we do, so node auto upgrades we talked about.
Nima, you're not presenting anymore.
Was it on Anthony's laptop or?
No. I have been signed out.
That's strange.
Maybe the meeting kicked him off.
If you can't get in, I'll share. I'll wait for you.
Slides were we on 250 something.
83. Yeah, so might as well be that.
Yeah, so node auto upgrades we talked about. There's also node auto repair, another kind of cool managed service functionality, and that's basically, you have your nodes in Kubernetes. You have the concept of the liveness and readiness probes, and basically, pinging whatever new pod comes up, right? You don't want to actually start serving, of course, traffic or using it before it's ready and it's healthy, right? So the health checks will now tie into this. Is like, hey, GKU will constantly do that for you. If something is down, then it goes and checks, oh, the health check is no longer returning green. I'm going to shut it down. I'm going to bring up another pod. Another node. So this is the health check at the node level, which is your VM, which you have pods scheduled on. So it'll bring up another one or restart it, and then reschedule the pods. We talked about the multi-zone cluster with the replication, and the regional one, which also replicates your master across the zones within the region. Autoscaler. So autoscaler is basically increasing or decreasing your number of nodes within your node pools, right? So, and this goes back, this is one of those concepts that maps to compute engines, the VMs and the way that works in GCP. So you have your node pools, and they are part of what's called underneath in mix or manage instance groups, which you have defined as part of creating your pools. And then based on the usage of CPU and memory, it can decide that, oh, I need to expand I need to expand the number of nodes when pods, you're spinning up new pods, but there's no more nodes left to actually spin up the pods. So let's increase the number of nodes so you can continue to spin up pods. Now, the way it achieves this, just one caveat is that it recognizes that there's not enough nodes because pods are trying to spin up and they're failing, right? So it's a bit reactive in that sense. So just keep in mind of that, hey, if pods are failing to schedule and come up, then that's when it recognizes that there's not enough nodes to actually handle the number of pods that you are running. Security, this goes back again, not just GKE. This is across GCP, and the way encryption and security works is encryption at rest, and that includes data, and this includes data in GKE, in this case at CD, which is where your secrets are, and so on and so forth. Also TLS bootstrap for node master communication, TLS enabled for regional clusters for master to master. So this basically encryption in transit and at rest. Summarize that. Yeah, secure and pod-to-pod communications. And cloud IAM, and this goes to the concept of IAM for GCP. So everything you do with authentication and authorization and the limitations that you put on your for example service accounts, your RBACs and all those concepts. Move faster so we can get to the to the lab, and also I want to cover a bit of Istio on service discovery and routing within the cluster for you. And yeah, so this you kind of actually saw. So I have right now I've set up an Istio cluster as part of the demo, and you can see in your UI, you have your clusters on their Kubernetes engine, and if you go inside the cluster, you have a bunch of information of everything about that cluster, and then you can look at workloads, which shows you everything that's running in that cluster. So it's talking about your UI and what's available there. Logging and monitoring. So Stackdriver is your central kind of package and product within GCP that captures logging and monitoring data across the board, and GKE is no exception. And of course, nothing stops you from having as much containers and additional logging and monitoring within your cluster. But this is what you get by default. You get your logging and you get your monitoring through Hipster and Fluentd that's being through daemon sets. It's being installed on your pods in order to collect metrics, right, and send it to Stackdriver. Load balancing, we talked about L4, L7. Happy to do follow-up sessions, to any deep dives if you want. You have follow-up questions.
On the Stackdriver, is that also something we can ask you about?
Yes, absolutely.
Yeah. Okay,
absolutely.
cool. Yeah, we're just also setting that up. It looks pretty nifty. So
yeah,
might be some questions.
yes, by all means, reach out to us, and they will be your first line. But
Yes.
we're happy to talk to it as it relates to GKE
Right.
and how to extend it beyond. If you have ever looked at Kubernetes kind of logging and monitoring documentation, you can see there's about 3 different best practices that does different types of logging, and because you have container level, pod level, node level, and then cluster level,
Exactly.
basically visibility, right? So across that, you can define at what points you're capturing data and where that data is going. Beyond everything that goes to Stackdriver, anything beyond that you want to get, you set up your own sidecars, you capture those, and then you start writing it wherever you want, whether initially it could be log files, which is in the node, and then you obviously rotate those, and are those being backed up? So there's best practices on how to set those up. But to start, you should definitely have a look at and see what Stackdriver already.
Yeah, I'll dig down a little bit deeper. So we don't need a sidecar for the Stackdriver, right? It comes.
No. So this already. So the 2 that we have listed, so Fluentd and Hipster, are the 2 that are already in there, basically, within your system, and they're capturing and sending information. to stack driver already. So everything you see in stack driver is coming from those areas. Multi-cluster ingress, it's something called there's GKE and the GKE team, the product team, they've done a lot of kind of brainstorming session to see the use cases, exploring the use cases of federations. It's whether or not federations in general are a good thing to do is quite often had been the answer is like, it may not be worth the headache because you actually want to achieve certain features that you now have to deal with setting up a federation and the control plane and all that, which exponentially increases complexity of the system. So the GKE team is working on bringing some of those features of the most common use cases directly into GKE so that you don't have to deal with federations. You still get it as a feature with your clusters. And multi-cluster ingress is one of them that you can actually, in GitHub, you can go have a look and look at the source code. But that's one of the examples of, hey, you don't actually need to set up federation to get multi-cluster ingress set up. Something. It's an alpha.
Alpha, okay.
So you can go ahead and spin up an alpha cluster in GKE and play with it. Alpha clusters are 30-day lifecycle clusters. We do that because we know otherwise customers are going to just run them and then they want to go production and next, hey, what happened? These features, and SLA is like, no, this is alpha, so we'll shut it down for you to make sure you don't end up using it for anything more serious than just testing and sandboxing. But you can get an idea of how it's working in there, and you can have a look at the source code as well. Storage, yeah. So I mean, these are part of integration with GCP. Everything that you can connect to, of course, all the storage options that are available within GCP, naturally you can connect to through GKE. And what you use, right? Should you decide to run a database as a stateful kind of workload in your cluster, then you're gonna, stumble upon these quite quickly in terms of, hey, I want to have a persistent disk or I want to have a local disk, and then you go and read about, what does it take to run stateful sets, and then the ordering and the persistent IDs so that when a pod goes down and comes back up, it can reconnect obviously to the SSD where the information is, and so on and so forth.
When you say dynamic volume, what does dynamic mean in this context?
Sorry.
You can provision volumes by creating a disk or persistent volume.
Yeah, so persistent volume claim would be the ones where it ensures that you're getting specific ones and you can reconnect to specific ones. The dynamic ones is where you can have just dynamically, you say this is how much I want, but it's not necessarily a stateful workload. So you don't care, you just want some memory and you want it to be on, let's say, local SSD because you need the high performance, but it's not something that you're saving information into and you want to persist through long time. You just need access to that performance at that kind of local file system. And so there's no guarantee that if that pod goes down and comes back up, it'll reconnect to that, right?
Yeah. Okay. But it would create a volume. Just, the data would be gone.
Yes.
Right.
I actually, I don't know if it tries to reconnect to the same one, and if not, or it's just no guarantee whatsoever. I know it doesn't guarantee, but I don't know if it makes an attempt or not.
Can I just ask a question for distinguishing between the GCP persistent disk? Is there another alternative for storage within the cluster that acts like GCP, or is just GCP like the best way to have a place to store data that's shared between nodes within a cluster?
As far as running your cluster in Kubernetes?
Yeah.
But I mean, you can connect it to anything you want, and that includes things external.
I guess so. In GCP, if you're just using local disk, your options are persistent disk, HDD, magnetic, persistent disk SSD, which is high performance, and the local SSC, which is like super, super high performance. Falling outside of that is like picking a database to actually just put your data in separate service entirely. And then
The blob
outside of
storage,
that
depending.
is a SaaS, yes, that you're pushing your data to. But in the context of disk, those are the three options in GCP. If you were to run Kubernetes in your own data center, then you might have other storage options you could connect to. But in GCP, those are the options.
Yeah, so we talked about it, but about VM performance and sub-minute boot times, preemptables, and that includes preemptables with GPUs as well. We have that.
You probably want to just do Istio, I think, right?
Because we have 30 minutes left and STO is like 20 minutes, right?
So we have a lab. I mean, we can send you the instructions for accessing it, and if you want, you can execute it on your own time. That's an option. If you really prefer to do it here, where you can have me like watching over your shoulder, you can do that too. Otherwise, we can just continue with the Istio stuff.
For Istio, we tried that. Are you talking about a Istio lab? Or?
No, this is just a Kubernetes, a GKE lab.
Yeah, so if you can send that.
Okay. Yeah.
So you guys have played with Istio before?
Yeah, I did. And I think Carter did too, just a little bit. And so I deployed what you were showing, workloads. I think the book review app.
Cool.
So we deployed that, and then I discovered that it's mainly for meshing between services, creating a mesh between services, and it's big on security between service communication.
Right.
So those were the two biggest advantages that I could see. But we were more focused on how to have two services talk to each other, which I think GKE should give us something out of the box. So that's where we were like, if we can use that, that will be good enough for us to bootstrap, and we can come back to Istio for meshing or TLS and stuff later.
Right. So yeah. So it's another another layer of abstraction now. So we were at GKE. Now we're going to go up another layer. And yes, so a major portion of what you mentioned is it does focus on making it easier to do communication and security and authentication at service level within a cluster, right, inside the cluster. So that's currently the what Istio kind of where it shines at, and obviously it does that in order to kind of, this is the ultimate goal of separating and decoupling code for operations to actual code of your program, right? Because everything that you do with from releases, A/B testing, canonical releases, to any kind of service discovery and the traffic flow and everything that has to do with ensuring policy in terms of should two services be able to talk to each other, and what does that also mean across if you have clusters or multi-clusters that's going across from GCP to on-prem to, for example, AWS. It has an adapter system, right? So that you have all these policies and rules and everything, for example, coming from different systems, and that translates into a bunch of set of rules for Istio, and then it takes care of the management and forwarding of traffic and kind of authorization of that.
So our immediate use case is for two services to talk to each other, not that, okay, these third service should not be able to talk to this. That's not our priority right now in Bootstrap phase, at least.
Yeah.
All we want to do is one service be able to talk to another one in the prescribed way. So, I mean, we know we can get the IP of the other service and put that IP in there. That would be the worst way to do it, because next time you deploy it, IP is going to change, right? The cluster IP of another service. So how can one service just refer to another service, let's say a user service? So all we hard code is user service / URI.
Yes.
And how do we do that in GKE in the prescribed way so that we can achieve that communication? That's what we're looking for.
Sure. So do you guys want me to cover kind of is there in addition to kind of service discovery and routing, there's the kind of security authentication authorization and also the kind of telemetry, kind of dashboards and visibility that you get. But I don't know, for example, in terms of canary releases, A/B testing, fault injection, circuit breakers, that's also the kind of things that Istio does a really good job at.
Yeah.
But if it's not your focus at this point, then we can table that. We can go back potentially to the lab and kind of work through some of the things. And
It's up to you guys. I mean, what do you think is most useful for you?
because I was basically going to go cover the fundamentals and then show you a couple of examples of traffic routing management and how easy it is by you have YAMLs, right? And you define rules of routing, and how it's achieving that is by having Envoy proxy as sidecars that is injecting.
In the
your
lab, I
system.
think that is always useful to see things in.
Yeah, and actually, I'd love if there's time actually to pose a hypothetical to you guys for using Kubernetes for the pipeline processing that we do. It's actually just as I've seen all this so far now, it's actually come to kind of focus where the pipelines API that we're using, I don't think is future-proof, because it just seems Kubernetes has a very sophisticated way of allocating resources to different workloads, perform processes that we need to do. And I can envision a time where the pipeline API, its method of spinning up workers is very simplistic, right? We tell it we just need 10 scatter nodes, and it'll just go start up a VM, like I was saying before, perform its work, and then tear it down, right? So it doesn't have any notion of having a pool or having more sophisticated scheduling or anything further than that. It just, that's all it does. And it appears that the library that we're using to carry this out they don't have any plans to incorporate with Kubernetes in the future. So that makes me, sort of make me want to rethink the approach and just to maybe show you guys what we plan to do and maybe just get a quick opinion on whether Kubernetes is more appropriate for it or the pros and cons.
Yeah, so Ed, just curious, I was wondering if you talked to Wyatt regarding if Cromwell has plans to be containerized. Because it already has that kind of job management for your kind of genomics use case specifically.
Yeah.
So you're thinking about whether or not to kind of build something on your own, but it's more containerized, more Kubernetes native, or do you want to kind of use the Cromwell project and see where it's going on in the future? I was just wondering how much clarity you had into the roadmaps of Cromwell.
Yeah, so no, I didn't specifically ask why that question. I think that's a question that we came across in passing, and I thought you mentioned that Kubernetes would not be supported. I checked on the Cromwell forums to see if there were any plans, and there were a couple of questions surrounding it, and they said no, we're not going to support it. But no, I haven't asked why specifically that question.
Yeah, so I would I personally think that maybe it's a better discussion to have with Wyatt because he has more of the context in terms of the use case and then the clarity into where the community project is going. What do you think, Ed?
Yeah, that's true. I guess the question that I had was a little bit more around the scaling and pooling ability that Kubernetes offers, or whether that feature meshes well with what we're trying to do.
Right.
So that's the only reason why. That's the only question I really had. That's I think relevant in this forum.
Yeah. So I mean, if you want to help us better understand, like you said, what you're working on now,
Yeah,
what's coming, and we can kind of talk to how Kubernetes can help, and potentially a good match. Because if it's not a good match, then obviously we don't want you to use it.
Yeah. So yeah, we'll maybe use this.
I mean, we're definitely going to use it for the bulk of our system, but specifically for the bioinformatics pipeline.
Yeah. No, I mean.
Yeah.
For that specific.
Exactly, for that use case.
Okay. So without knowing or having to understand really what these demultiplex really is, I'm just thinking about abstractly as there's a series of steps that happen in our processing pipeline, right? Where so 2 is prep, And so what's happening is that what the input is into this step is just really a series of files. Right? These are files that are from our DNA sequencing machines. Right? So they're, our DNA sequencing machines just output a bunch of like data files. And so we run them through something called like the demultiplex step, right? And then it does some stuff. It chops up the files in certain ways and does some processing. And then we go to sample prep. And now from sample prep, what we would like to do that's different from what we're doing now is to parallelize, right? So in step 3, something called correction. So what we want to do is to basically run the correction step on a whole bunch of different VMs, right? And then what will happen is we will join at this step, get the entire output, right, and then move on to step 4. So I guess in the Kubernetes context, what I'm wondering is that this is something that Henrik you mentioned earlier, which is if we had a pool of nodes available so that we can just easily distribute the work onto them. Whereas in the Cromwell world, what happens is that it's a VM start. VM start and stop. So what I'm wondering is, after viewing all this, whether this type of like processing is something appropriate to Kubernetes.
Yeah. So what happens in step 3 exactly? What is the processing? What software is being used? And so it sounds like it's taking some data and processing them, right? And what is that exactly that's processing it? And
it's a combination of Python and some third-party tools that are a binary that we use.
Right.
Are you asking like specifically what?
I don't know what you're looking for there.
Right. So the reason I'm asking is, I mean, what you're doing there, does that fall more in the domain of more of an ETL type of job that it's doing? Is it just doing transformation of data? You grab it, you parallelize it, and then now you want to take it to the next step and do something.
These are very large strings of genetic DNA sequences, right? So it's not like typical database type ETL, if that's what you're thinking of.
How large is the data that one VM or one unit would handle? Do you have a rough idea of that?
Per run or per?
I guess per
node
or per node.
So for each file going into the correction step would be 0.5 to 1 meg, let's say.
Okay.
There's like 400 to 1,000.
Yeah, 400,000 per sequencing run, and there can be many sequencing runs.
Oh, so it's handling 400,000 of those like in series.
Yeah.
Interesting. And what's the latency of that step 3 right now that because you tried on the VM, it was too slow, right? So what is your target SLA on that?
Yeah, well, the worry is right now it looks like a VM that I start up and finish with running just a simple task just to echo hello world takes about 3 or 4 minutes.
Okay.
So that includes the time must be to pull the image, allocate the VM, start it up.
So that was just a sample test. I'm just starting a VM and stopping it. Oh, I see. Interesting. And so step 1 and step 2, is that like one box that's just doing all of that? Is there a reason that those aren't parallelized?
Correction is the majority of the analysis time, so we're shooting for that. It's like 95% of the runtime is there. So we're trying to reduce that for now. I mean, of course we can shoot for those, but we're targeting the main bottleneck right now, which is correction.
Okay. So Nima, you can chime, but I think so I think it's definitely possible. The advantage you'll get is if you have a pre-allocated pool of compute, right? The speed up will be the ability to start a pod to handle that work very quickly, because pod startup times are really fast. assuming you have the image on that machine, because then you're not waiting for a virtual machine to start and then stop. I'm a little surprised that the start and stop time was in the order of minutes. We generally tend to be faster. But
this was on GCP.
That's what surprised me. So that I think you'll see a speed up alone right there. I don't think I heard anything, like if you're just running Python and some third-party libraries, packaging it into a container image, I don't see any issues with that.
Well,
so
the one thing is the VMs that you're running as part of your startup script process. What's happening there? Are you grabbing a whole bunch of libraries? Is it downloading them and then installing stuff, and then that's when it's ready? And obviously that becomes part of your preparation. Or have you actually, I ask because if you could create a custom image, right? You can spin up a VM and install all those libraries and everything you need, and then take a snapshot of that, and then that becomes your image to use for any VMs that you spin up, right? And then from that point on, then all of that downloading, installing, everything, is no longer part of the equation as part of how long it takes to start up your VM. So when you say VM start, is it just a default VM of GCP, or is it starting a VM and then getting it to a ready state to actually accept jobs, which requires a bunch of scripts?
I'm using a Docker image that I obtained from Cromwell, right? So Cromwell built this base image to use on GCP, and then I modified the Docker file, just to add, some extra stuff that I need. Then I built it and pushed it to the GCR, and then from there, that just said use that image. But it's not rebuilding the image, is it?
So that might be where, how large is that image, the Docker image?
It's 1.3 gigs.
Okay, that might be where the hole is, because right now what you're doing is you spinning a VM. That VM doesn't have the image, so it's pulling it down. So you're time bound on the pulling of that image right now. So if there's any way to bake the image contents into the image file system itself,
right? So
that when it launches, it's like, well, I already have the image on the node, I'm done, and then it can start it. That's gonna be much faster than. So I think there is a way to actually make the VM start that you're seeing faster.
Okay.
I would start there and just see if that works. And if that, then it'd be interesting to know like where are you actually time bound. Because our VM start by itself shouldn't be that slow.
No,
it should be on the order of sec.
Like 20 seconds.
Yeah, it's actually not too fast.
So that's definitely contributing. May not necessarily be the only thing. Other than pulling that image, the 1.3 gig image, is there anything else that happens after that? Is there any installation or compilation that has to happen before that system is ready? Okay.
What is the latency if we took a snapshot of a VM, made a custom VM, we wanted 400 machines all of a sudden and had to take that snapshot to build upon it. Is there latency there by taking a snapshot? Or
well, you take the snapshot at like some previous time before, and then you add it to your library, and then it's just there. And then when you're spinning up a VM and you're just using that as
there's no latency with using like a snapshot.
No,
versus the default. That's what I'm trying to say.
Yeah, no, it just becomes another kind of image that becomes part of your library. So the ones that GCP providing you, and then there's your custom ones. And now you're saying, hey, all the VMs that I want come up, I want these. So even if you can't necessarily, let's say not everything in that image that you're pulling down is always static, and it's something that gets updated. Maybe that's why you start to always pull it down to have the latest version. But potentially there could be a big portion of that is static, and then 10 to 20% of it is changing. So you can still bake that 80% of it that's static into a custom image, right? And then be loading up your VMs with that, and then you're just pulling down 50 megabytes, right? That's potentially changing. So that it depends.
So it's possibility for optimization, and just like looking into because I'm not sure.
Yeah. So from that perspective, I mean, you can just directly be doing this with VMs, but Kubernetes will do a great job. You can have a cluster that's up and running, right? And then if the cluster is practically down to 0 nodes, it's not costing anything, right? But it's already up and running and it's set up, and then you can scale it out to run a particular job, right? Especially if it's preemptible. it
That's
can just
actually a nice point to just
Because it
get
is-
this cluster up and running with 0 nodes, and then we can scale it up and down as needed, right?
Yeah.
Because all these jobs are going to come ad hoc, right, from customers.
But regardless, you have to figure out you don't want to have 1.3 gigs being downloaded every time a single VM goes up.
Yeah.
So I think that needs to be figured out first, and then we can look at the pros and cons of just using node pools and VMs versus GKE specifically to see if GKE gives you any benefits beyond just the pipeline you already have. It's already spinning up VMs up and running. But I'm assuming naturally one VM is only getting one one job, if you will, right? Whereas with GKE, then you're talking about containers and pods, and then you can have multiple on a single node on a single VM, right? There's those things to think about in terms of optimization. But yeah, even for your VMs, you should potentially, because this is very much a batch processing type of job, you should be looking at preemptibles in terms of cost perspective. It's something like 80%, I think, cheaper.
I have a customer who's doing something very, like, not the same, but they do like machine learning experimentation. So they don't have like a production app that's running all the time. And they just use virtual machines. They do something very similar. They bake the Docker image into the VM image so that it's the bulk of it is there. And they're launching like hundreds, if not thousands, of machines for like a single run. They're getting kind of the latency that they want. So I think this actually could work.
Yeah, I'm guessing this is because like this load and the workload that you mentioned, Chris, it's all very compute heavy. So in that scenario, they'd rather be on a large instance, so they can, correct me if I'm wrong, they would rather be on a large instance where they have a very beefy CPU, so they can deal with all the compute instead of trying to spread that out on the GKE somewhere where the nodes probably are different.
Yeah, I mean, that's something that they can play with in terms of how much processing you need, and you can define and decide on the, and you can have several pools with the different machine types and check out the performance and see if you want to use more powerful machines with less of them.
I think our challenge is because we have something running in AWS today, right, which uses a 64-core machine. But I think there's a limit that we tried, because some of this code is not ours, right? We're dependent on binaries, and we're not going to rewrite that for sure. Unfortunately, those have limits. So I think we had, 8 threads that we could run concurrently that, the machine was happy with, or the process was happy with. So in terms of, how big we can scale vertically has limits. So that's why we definitely want to scale horizontally. But if we need to, that was actually another question I had. Are there any limits in terms of how many nodes, or because, I mean, based on some calculations, we might need 4,000 instances spun up for a single run.
We have, I guess, a project limit of number of nodes, which is 5,000.
Virtual machines in a project?
Yeah.
That actually might be right. Yeah.
Something like 5,000. And I think that's a soft limit, but
I think it's doable.
Yeah,
it's just a matter of planning.
Yeah, and from a performance perspective, we can talk about theoretical values, but I think you should test it out, because even if you have the exact same machine compared to AWS to here, performances of various things differ because the way our hardware is set up and everything to do with networking. Our networking is drastically different. So you may not necessarily need just as powerful as a machine.
No, absolutely. But and that is great. And I definitely want to build in like benchmarking throughout the process, so that at each stage, each step, we know exactly how long it takes, so we can narrow down the bottlenecks. But I anticipate still, it might not be thousands of nodes that we have to spawn up. There might still be hundreds, and all this is still for a single run. So hopefully we get a bunch of customers, meaning we might have multiple of these happening in parallel. So now that's a real problem. And what Ed is trying to do is use the Cromwell and pipeline API to solve that problem. But this might be our plan B or even plan A. So that's really what we have to, because of everything that we're building here end to end, this is really the, how should I say, the biggest challenge, I think, from a infrastructure point of view.
So you're bound on the software to, you said 8 hyperthreads? Is that what?
David, I don't know if you.
Yeah, the software we're using, it's exponential, let's say, in the runtime. So we limit the size of the number of sequences per job.
Okay.
And so at that point, yeah, there's no real benefit past 8.
I see. Okay, and so because you're using like 8 hyperthread machines, then you need like a lot of them. Interesting.
Yeah, I mean, beyond the.
Got it. Do you have a rough idea of like, I mean, we don't have to get it now, but like if you have a rough idea of your peak, what you would think that might look like? Like
I
at
have
peak,
some
it would be
estimates,
this.
Yeah, I don't have it like at the top of my head, but yeah, I can try to find some.
Yeah, that would be really good to have, just
Right.
to think through what that would look like.
Scaling.
Yeah.
Perspective. Yeah. Yeah, I'm curious to see. As first step, we definitely need to optimize the just VM startup perspective, and then beyond. I mean, if you get to a point that you need more than 5,000 nodes, then you start setting up like multiple projects, right? And it could be
Lots of different options there.
Yeah, there's lots of different ways to design that.
Right, but yeah, as soon as you take some of these abstraction layers, whether it's projects or I don't know clusters, then we might we might encounter other boundaries, right? Then we need to handle this system differently from a CI/CD point of view, right? And how cross communication happens if it needs to. So we need to be very careful.
Absolutely. Yeah, based on what your constraints are, what capacity that you're expecting, then we can certainly work with you. And we have a whole team of solution architects which specialize in different industries.
Okay.
How to what the best practice for the design would be.
Yeah, no, I'm happy. Maybe this week we have time to try to come up with some good scenarios, like because we are also developing this, right? It's ongoing. So some of these things, bottlenecks that we see today might maybe go away, but there are certain things we know for sure. So maybe come up with some kind of scenario and then shoot it over to you guys so you can take a look.
Absolutely. Yeah, that would be really great.
Cool.
Yeah, and it sounds like there still might be some questions around service discovery. Maybe we can kind of, I think we're already there with, if we're not doing STO, it's just kubedns, right?
Oh yeah, so just the default, when you stepped out for a minute. So the communication between two services using default Kubernetes kind of features, and kind of diving into that. I don't know if we want to set up a session to go through that, whether it'll be in person or it can be Hangout, or we can even start if you want to list kind of questions within that domain through like a follow-up email, and then we can either guide you through that and then kind of do a Hangout session or in-person session.
Okay.
The format doesn't matter as long as we can help you.
Right.
Yeah, I think email communication would be better in this scenario, because then we can go through it, and where we need help, we can ask questions. So like one particular problem I encountered, and which I was hoping to get answer here, was how do we debug pods? So let's say we deploy a service. So you can take Istio's example, where you have review app version 1, version 2, and so it says, if something went wrong, now how do I debug? What's the concept there? Like, because in traditional way, you can just SSH into a VM and tail the logs or audit logs or whatever. So what are the counterpart concepts in pods?
So you can do that. I mean, in now in your cluster, you can SSH
Okay.
into pods.
So I can SSH to the kubectl, the master, I guess, is what I can SSH into. But
No, you can't SSH into the master node.
Okay.
But the worker nodes all have all the container logs are there. So if you really want to, you can SSH into that and be like Docker log container. On the other hand, you could just use kube control or cuddle, whatever.
Yeah.
Pick it, and then just say logs. It uses that backend and it spits out everything that it sees. And you can also filter it down to the specific container part of the specific pod.
Yeah. So I saw the logs on the UI. So there you can narrow it down by cluster and then by the service.
Yes, right.
In this case, the problem was a level before. Like I could discover the problem in events because there was something wrong in the deployment file. So it wasn't going to show up in the logs because the pod never actually came up. So I eventually found it in events tab where it says failed to find this volume or something like that.
Yep.
But other than that, is it just the logs view that can help, or is there anything else?
Yeah, I mean, kube control events and logging, those are the two primary things that I use.
Okay.
I don't know, is there anything specific else that's...
You could have a look at Zipkin
Okay.
to set up on your system as a tracing
that's right.
kind of approach. This is one of the things that, for example, works well with Istio, but you don't have to have Istio to set up Zipkin. So I would recommend looking at this in order to, it is absolutely a challenge because now this is one of the classic challenges of your system now, services and across many VMs, and then how do you trace an actual event that's happening? And there's tons and tons of logs that come out, of course, at the different levels. And so it makes it hard, but tracing approach, and Zipkin is just one of them. It is one way to kind of get a different view of what's happening. But yeah, we can think of kind of more specific ways to approach something. Like you can just give us an example of something. And
I know it was
of different ways.
standard case, like I tried to deploy something, didn't work, so how do I debug it? So events helped.
Yep.
And once it goes in events, I guess logs take over. And let's say service is not, app server is not coming up, then it should show up in the logs. Right?
I mean, you can also see like the container creating, it failed. And so if you do a get pod and then filter on the ones that are not running,
Right.
you can actually see the pods that failed to create.
Yeah.
And you can actually see if anything happened. But
Yeah, I saw that, and then
yeah,
the thing I had to look was for events.
right.
So
Because
event showed me that.
yeah, because the pod itself isn't cluster
Right.
aware. So like that's more captured by the event level.
Okay.
I would say service discovery, like the short answer is kubedns gives you a name.
Okay.
You should do, like in your code, you don't want to be hard coding in VIPs. So if you code in a name, it doesn't matter what the backing IP is, right?
Yeah.
That can be your config map, right?
Okay.
To just switch that out. The rest Kubernetes takes care of.
Okay.
We can talk about specifically how it watches and updates pods. There's a thing called endpoints, and it says like, for this service, here are the different IPs that are associated with it, blah, blah, and then all that stuff. But
So
usability perspective, that's what
right,
you
so
do.
we can mention one service or refer to a service in another service by that name that eventually kubedns will expose it.
Yes, yes.
Right, so I'll look
It
into
is
that.
different though if you're going cross cluster.
No, yeah.
So
right
that's
now
the
we
only
don't
one I
have
would
any.
be, yeah.
Okay, I'll start from there. Thank you.
Seems like our time is up. Thanks so much, Chris and Nima, for providing your expertise. And I hope it was helpful for the ClearLabs to start on.
No, that was
making
super.
GKE.
Yeah, thanks a lot. I really appreciate it.
Yeah,
you guys started. Also, thanks to Anthony also.
Yeah, I will pass that on. Yeah, thanks for dropping by our office. And then definitely I will follow up on the two items that I think we have some interest on.
Yeah, exactly. I also have some points, but yeah, let's just.
Yeah,
follow
we'll
up
keep
on it
the
maybe.
conversation going on email.
Right.
Yeah.
Can we add a few more?
Yeah.
I mean, because the scope of this is more management side. There were two things that came up that I didn't really have time to ask about, which was secret management and generation, which perhaps maybe using Helm to set up some sort of a dynamic configuration for different clusters.